the stream begins. So there's a few things that I want to get done today. There's a subject of content called AI Planning for Autonomy. That's a subject that I'm taking at uni, and I'm just going to do an hour, 2 hours of that, just to understand the content before uni starts up next week. Then I'm going to do some Leetcode questions, one Leetcode question, we'll say, before following up with scheduler development when I have the time. So it should be pretty productive today. And, you know, the internet might or might not drop out during parts of the stream, but it'll all still be running, hopefully, fine. Because yeah, it's not going to stop until I stop it. But it will drop out a bit every now and then, possibly because of the weather. Because when it's really windy or when it's really rainy, it cuts out my internet quite a bit, which is interesting. You know what I mean? All right. Here's what's going to happen. Let me just do monkey type. Just one session of monkey type. Man, hands are pretty cold, I won't lie. That's why I'm wearing all this every day of the week. Alright, done. We're going to now head to APA. Just going to do a question. How do I just close tabs? It's not a problem, to be honest. Doesn't matter, okay. I will look through some of this. And just trying to think. I want to pull out a plan just on the side so I know everything. God damn, there's quite a bit of stuff that I gotta maintenance on today. It's okay. Okay, so this is the first thing that I just gotta do. I believe, let me just open up my mail on the side. There was something that I had to do. I believe I'm just going to read something related. Okay. Well, that's not it. Okay, week 1, intro to AI, lecture, videos and questions, no tutorials in week 1. That's fine. Yeah, so this is all the content I think that we need to worry about. Let me close off that email. Week 1, Uni Hack, welcome back, make a difference. Okay, there was another thing. Ooh. Run Pro. Thank you for subscribing. I'm not sure if that was on Twitch or YouTube that you subscribed on. Okay. Got some other stuff going on here as well. Doesn't matter. Oh yeah. Okay. Lo-fi music in the background. The other thing though is there was an experimental thing on on a stream that you can do, which allows you to play music in the background without you having to hear it, I think. Probably can't figure it out now, to be honest. It's fine. You know, I do want to open Twitch on the side here. Hello. Nah, that's not even correct. APA. Alright, I'm gonna have to close all these. APA. Store from bookmarks. APA is just out. Close, close. This is all it is. I'm just gonna get my stream. Okay. I have two places. Alright. Let's see. Next week I'll include a post handout with embedded answers to questions discussed in the video and worked examples if applicable. Oh man, my problem is I also need a way to store all this. Alright, let's see. Okay. Good. Okay.
Hello everyone, welcome to AI Planning for Autonomy. I'm Mir Lipovetsky. I'm going to be your lecturer for the first part of the subject. Later during the week, we are going to do a live lecture where we're going to cover a little bit about what is that we're going to be learning here, what are the logistics of how we're going to do all the learning, and I'm going to also clarify what is AI, okay, or which part of AI we're gonna be learning. But in this first video, what I want to do is to give you a short history of AI, okay, just because it's important to know how all this started. Okay, so AI per se was coined in a meeting in 1956, a Dartmouth meeting. The founding fathers of AI are these four researchers, scientists. You might know their names. John McCarthy, he was the inventor of Lisp, or Prolog, for those of you that are familiar with logic programming. Marvin Minsky is a famous researcher that invented the area of cognitive science. He was very influential there. He also wrote a very important book called The Perceptron, which pretty much caused the first AI winter. Okay, so AI had several winters and summers, so there's a lot of hope on the possible achievements of AI. In the 70s, he wrote Perceptron, and he pretty much killed the area that was very much nascent. It was a new area called machine learning, and neural networks were very strong at the time. And he wrote Perceptron, and he pretty much showed that at the time they couldn't do much. Okay? He's also known because he was a figure on communicating science, so he worked with Stanley Kubrick in Space Odyssey to tell them a little bit how to actually be accurate, scientifically accurate in their film. So it's an interesting character. Nathaniel Rochester, he was one of the founders of the first computer that was commercialized at IBM. And Claude Shannon, I think he doesn't need an introduction. He was very influential on all areas of computer science. Information theory, he's very known for his contributions there. So the first three researchers were quite young. Shannon was a well-established researcher at the time, and they put this proposal to Dartmouth in order to describe and start working on the area. At the time of the proposal, AI per se, they didn't have the name AI, so they coined the term in that meeting. Interestingly, you can read about the proposal. What do they wanted to do? I mean, they were trying to proceed on the basis that every aspect of intelligence can, in principle, be precisely described, that a machine can be made to simulate it. Okay, so, I mean, it's quite ambitious, but they are talking about simulating intelligence. Okay, I'll try to make this more clear in the live lecture. What does it mean to simulate intelligence? But for this video, I'm gonna leave it there. When we look at 1963, so 7 years after the starting meeting where they coined the term AI, there was this book published, Computers Are God. You can access this book in the library. And what I like, at least, is to look at the contents to understand what was the research in 1960. Okay, so we can see that the first chapter, or first section, was "Can a Machine Think?" Okay, by Alan Turing. Okay, Alan Turing is also known to everyone. He was one of the founders, even like before computers existed, of the computational model. So there was the deep question of whether machines can think, and that chapter actually, I really recommend everyone to Google and read that chapter because it's quite interesting. Then we had a section on machines that play games. I think that still this research is very much active. We've seen how a few years ago Lee Sedol was beaten in the game of Go, so this is still something that research in AI is very active, playing games. Then we had machines that prove mathematical theorems. Okay, this is about logical inference, so how to prove that knowledge is correct. That's a very important area and it's very active. Two important applications. So since the 1960s, applications of AI to society and industry were already there. Question and answering machines. This is pretty much natural language processing or chatbots, if you wish. And then pattern recognition. Okay, so pattern recognition is the area that machine learning actually nowadays shines quite a lot, right? So if you think about image processing, that sort of area is what belongs to pattern recognition. When we look at the kind of research that was being done in the 60s, 70s, and 80s, everything had to do with programming and representing knowledge. Okay, so you would think about how to represent the knowledge that the program or the AI program would need in order to solve a specific task. Okay, so at that time was where Lisp and Prolog was invented. Rule-based programming is basically, you can think about it as lots of if-else statements. And expert systems. Okay, expert systems were systems where there was a lot of effort, of human effort, of encoding rules in such a way that you could have diagnostic systems for medicine and many other applications. Okay, so in the 70s, the whole AI was dominated by having huge labs, getting a lot of knowledge, human knowledge, encoded into programs and encoded into knowledge. So if you take yourself, medicine and many other applications. Okay, so in the 70s, the whole AI was dominated by having huge labs, getting a lot of knowledge, human knowledge, encoded into programs and encoded into knowledge. So if you take yourself and you put yourself as a student back in the 60s, 70s, and 80s, typically you would pick up a specific task, you would try to analyze it, understand how it should be solved, and you would try to capture this reasoning as a program. Okay, so you would pose a theory that's how solving a problem should be done, and then you would program that theory and you would test it over a few examples. Okay, and there were many great ideas at the time, but there was a problem. Okay, and the problem is methodological. Okay, and the key issue, I think, is this one over here. Theories expressed as programs cannot be proved wrong. Okay? So whenever a program fails, it can always be blamed for some reason, okay? Missing knowledge or other type of reasons. So there was a lack of scientific methodology at the time. So whenever you had a program that was failing, there were three approaches to solve it. You would narrow the domain, so basically you would say that it works only for specific cases, and obviously there's a problem, which is that a solution like that is not general enough. So there are many possible variations that would make the solver fail, or the AI system to fail. So the lack of generality, it was a problem that basically caused one of the first AI winters. The other possibility is to just accept the problem as a demo, but yet again, this has very limited scientific value. And the alternative is to fill up with more knowledge, and then you would end up with huge systems that nobody could understand when do they work and why they work. Okay, so this approach actually hasn't been successful, because you can always find another instance or another problem that makes your system to fail in the problem. So that methodology, that lack of scientific methodology, led to the first AI winter. Okay, and at that time there was coined the term good old-fashioned AI, where they say that AI was just applying rules, and that's it, and that's not intelligence at all. Okay, many criticisms that were valid, partially valid at the time, they're less valid now. Okay, and I will try to clarify why is that the reason. So once we reach the next
Okay. I gotta read some of this.
60-second adventures in thought. Number 3. The Chinese Room. Can a machine ever be truly called intelligent? American philosopher and Rhodes Scholar John Searle certainly can. In 1980, he proposed the Chinese Room thought experiment in order to challenge the concept of strong artificial intelligence, and not because of some 80s design fad. He imagines himself in a room with boxes of Chinese characters he can't understand and a book of instructions which he can. If a Chinese speaker outside the room passes him messages under the door, Searle can follow instructions from the book to select an appropriate response. The person on the other side would think they're chatting with a Chinese speaker, just one who doesn't get out much. But really, it's a confused philosopher. Now, according to Alan Turing, the father of computer science, if a computer program can convince a human they're communicating with another human, then it could be said to think. The Chinese Room suggests that however well you program a computer, it doesn't understand Chinese, it only simulates that knowledge, which isn't really intelligence. But then sometimes humans aren't that intelligent either.
Bogboy says quite a few things actually. The second I joined, it's just breakfast. Might as well boot up VS Code myself. Never mind, I forgot how to program. Fun fact, I did IT in college for 2 years but can't program. This is due to the fact that I decided working with my hands was more fun. Oh, okay. This is the friendly reminder to anyone in the chat that yes, the computer science degree your parents want you to get might make bank and make them happy. It's never too late or too early to do what you love. Alright, boy. Fair enough, makes sense. I agree. Wholeheartedly. Do what you love. Alright, the problem is, I realize the chat isn't being displayed. Something I'm gonna fix. Just on the side. But why? Control O. Just gotta see. It's just it's the exact same. It's not showing. Taking break alerts. Unless it was showing and it's just disappeared. I doubt. Wait, let me see. How long ago were your messages? Yeah, tell me. Alright, well actually might as well good words. Nope, that didn't even that did not work as intended. Okay. Test. It's not showing up. Okay. That's fine. Test. doesn't show up. I'm going to just try it with a new browser source. Well, that shows up. Alright, sure, so 400, 500. Alright, rename. Botrix chat. Gonna rename this old one. Can't rename it for some reason. Okay, Botrix chat. See, chatted. Rename Botrix chat, and it's just about the same size. I think that's about good. Let me see. I think. Oh. Okay, no. Okay, I'm just tripping. All right. You can remove that. I can type as a test, maybe. Test. Just gonna see if it works. I expect it to work. Okay, it does. It does. It does work. It does work. Okay. I'm gonna delete that message now. Okay. I'm expecting to work from now on, so that stream messages can work, and I can close some tabs. Okay. All right, let's go. my god. Okay, yeah, I do want to see how to stream isolated audio only to stream and only to stream. How to separate desktop audio from music for streaming. How to stream audio only from specific. Not how to put background music in stream. I hate looking at these videos. It's not what I want to do. That's kind of cool. Let's have a look.
This aux input, at the very bottom, there's this mute button. Right now, I cannot hear any music. Now, if you look in OBS, I did not mute it in OBS. So the video, you guys who are watching this right now should be able to hear this music. I can't hear anything. It's totally silent. So yeah, it's pretty cool. And also another thing, if you felt like the music was too loud for you, but your stream is not complaining, they think the volume's fine, you can change what you hear with this knob right here. This does not affect the levels that your streamer hear, right? If you look in OBS, if I lower this all the way, right, this is pretty much muting it for me. I can't hear anything, but you can still see.
Okay, well, voice meter seems to be the way, right? Alright, let's have a look.
A tutorial today. I usually don't do these, but I'm making a little tutorial for streamers. And basically the tutorial is going to be on how to separate the music that you play in your stream from the rest of your stream audio. So, why would you want to do this? Well, let's say you're streaming and you got like some copyright music going. Obviously, you're not supposed to be doing that, but I mean, you know how it is. If you've got copyright music and you want to make, let's say, a stream highlight video, you're not gonna want that copyright music in your stream highlight video, because then you risk, something like a copyright strike. So you're gonna want to remove the music for that. Or let's say you're streaming and your audience doesn't want to hear music. Maybe they don't like your taste in music. How do you accomplish this? Well, basically with these, you can see these two pieces of software that I have right here. This is Audio Router, and this is Voice Meter Banana. Now, let me just full disclosure, I'm not a pro at using either of these. This one's pretty simple, Audio Router. Voice Meter Banana is, you can do quite a bit with this program, and most of these features, the functionality, I'm completely ignorant of. I'll be honest, but I do know enough to do what I'm about to show you. Okay, so how do you get these programs? Basically. Here we go. So here's Audio Router. Pretty simple. Just Google Audio Router. I'll put the links in the description. There should be a GitHub link. You just go here. There's a 64-bit exe download link and a 32-bit exe download link. Anyway, get the one that you need. It's there. Voice Meter Banana. Here we go. So yeah, you can see all these pictures. This program does like 1,000,001 things. Okay, I don't use it for any of that. There's tons of stuff on YouTube if you really want to learn the ins and outs of this thing. You can figure it out. I don't know. It looks a little complicated, but there's info out there if you look. So anyway, just wait. Where's the? Here it is. So yeah, to install it, there's a little. They have a compressed version of it, and then they have just a straight exe. Just download the exe aux input. Right now what we're trying to set up. So what you're trying to do is you're trying to have all of your stream audio minus the music be directed to this voice meter input device. And then what you want to do is you want to have your music going to this aux input. That's basically what we're going to be setting up. Okay, so first thing you need to do is you need to set this as your default. And the first thing that you're going to want to do is that is probably going to tell you need to restart your computer, so do that. And then when you come back, you'll have both of these things here. And the first thing that you're going to want to do is you're going to want to change your default audio playback device. So how do you do that? I'm showing it to you right here. Just right click this little sound icon up here in the corner. Go to playback devices. Actually, I have my taskbar up at the top here. Windows by default has that at the bottom. You know, come on. All right, so anyway, you just go there, go to your playback devices, and what you're going to see is you're going to see two new devices that Voice Meter installed. One is called input, right, just straight up input, and then one called aux input. Right now, what we're trying to set up. So what you're trying to do is you're trying to have all of your stream audio, minus the music, be directed to this Voice Meter input device. And then what you want to do is you want to have your music going to this aux input. That's basically what we're going to be setting up. Okay, so first thing you need to do is you need to set this as your default playback device. Just click on it. Again, input, not the aux input. Click on it, hit set default, hit apply, then hit OK. Obviously, I've already done it, so I don't need to do that. Now, just be forewarned, once you do this, you will not be able to hear any audio on your computer, right? Because you changed the playback device. So in order to hear this voice meter input in whatever you're using to listen to your computer's audio, right? I'm using earbuds right now. They're plugged into my audio interface here on the desk. In order to listen to it on that, or in speakers, or whatever you got, you have to route that to, or you have to send that to your listening device in Voice Meter Banana. So as you can see in the program here, when you open up Voice Meter Banana, you're gonna see here two virtual inputs, right? There's virtual inputs right here. There's one right here. It's this whole thing. And then there's another one right here, right next to it. So as you can probably tell, this one that says Voice Meter VAIO corresponds to this device here, the one that you made the default playback device. This one right here, Voice Meter aux, corresponds to the aux input, which is where we're going to be sending the music, that we're trying to isolate from the rest of our stream. So in order to hear both of these things, right, your desktop audio and your music, you're going to need to route both of these to your headphones, your speakers, whatever. So the way you do that is up in this side, the right side of Voice Meter Banana, you'll see there's hardware outputs. They give you a choice of three, A1, A2, A3. All I do is I go to A1, click that, and I select my audio interface. Now you'll see there's multiple selections for your there probably will be multiple selections for your device. So I have one here, right? It says WDM. There's another one here, KS. There's one right here, MME, and then I believe this one is also going to my audio interface. I don't really know what the difference. I'll be honest. I don't know what the difference is between these different things. I believe they're like different drivers. Like there's WDM, there's KS, there's MME, there's ASIO. I don't know what the difference is. I do think they differ in terms of latency, and I've heard that WDM is pretty good in terms of being low latency. And a lot of the tutorials I've seen, people are using WDM, so I just use it. It works. So yeah, try that. If you have issues with that, try a different driver like MME or something. But anyway, so that's all I do. I select the device that I'm listening through, right, which was probably your original default playback device, right? I put that in A1. Then, in order to send both of these virtual inputs to A1, you just click A1, right? So I think by default it's like A1 and B1 for everything. You don't really need the B1, so I just make sure that A1 is clicked for both, like that. So both of these virtual inputs will now be sent to whatever device you're listening to. So now you'll be able to hear, whatever audio is playing on your computer. Okay. So we've got now at this point you've got most of this, you've got most of it working the way it should, except for you still have not sent your music to the aux input. So how do you do that? Use Audio Router, right? This is the final key, the final piece of the puzzle, rather. So when you open it, you'll see this, which is this is a pretty nice view. There's a couple different views, but you can see this shows all of the devices, the audio devices on your computer, and it has like volume meters, so you can do like a little bit of mixing here. But I prefer this view. You go to File, Switch View. You can go back and forth. If you switch view, you can see a list of applications that are playing audio, right? So as you can see on the right in this window, it says routed to. So it shows you where each of these programs is directing its audio to. So right now they're all blank, right? As you can see, there's nothing here. That just means that all these programs are sending to the default playback device. So if you want to change one of them, right? For me, when I play music, I'm usually playing it in like a YouTube playlist on Chrome. So for this tutorial, I'm going to be directing the audio from Chrome to the Voice Meter aux input. If you're using Spotify or you're playing VLC, like a playlist in VLC, you want to direct the audio from that program to the aux input. Okay? So to reroute the audio, you just double click on the application that you are going to use to play music. Okay? Double click, change it from default audio device to Voice Meter aux input. Hit OK. Now you'll see it will show that it's now routing the audio from that program to the aux input. Okay? And at this point we're good. Now one thing to mention is when you make changes to the audio routing in audio routing, Voice Meter Banana doesn't automatically see that change that you made. Right? It's not detecting like any changes to the audio routing. So in order for Voice Meter to see it, you have to hit menu and restart audio engine. Right? At this point, now Voice Meter will see what you did, and now all the audio from Chrome will show up here in the voice meter aux input. Everything else, game sounds, system sounds, everything is going to go through voice meter VAIO. Okay. Sorry, there was one thing I almost forgot to mention. So as long as voice meter input is selected as your default audio playback device, every time you restart your computer, you're going to need to have voice meter banana open in order to hear this in your headphones. So one thing I recommend is when you hit menu, click this option right here, system tray run at startup. This makes it so that voice meter banana always starts up when you start up Windows, right? Which is what you want, so that you can keep this as your default playback device at all times, right? Unless you really want to like go back and forth switching default devices, when you're streaming, when you're not streaming, you can do that too. But it's easier just to keep this as a default and make sure that voice meter banana is always running in the background, right? It's a little bit easier. So anyway, that's just a little recommendation. I think at this point we're pretty much done. So how do you set this up in OBS? This is the final piece of the puzzle here. All right, a little bit of what is this? Streamception, technically videoception, I guess. So in order to set this up, you can see I have two, in addition to my mic and obviously my webcam, I got two audio devices here.
Cool. No worries. We can close all of these. Okay. Ooh. Okay. I don't have local send, but I can install it through Choco. I think I'm gonna have to open Alacrity as administrator. So local Choco install local send. Hopefully that will work for me. Okay. I got to install local sand on this device as well. Allow access. Just gonna send this file from our downloads. And delete some of these files. What's this one? Oh, right. Let's close. We can delete all of these. Delete these as well. We've got sideberry snapshots. Just keep sideberry snapshots, it's alright. But these two files, we'll see. Here we go. Receive. Where does it get sent to? See the history. Show in folder. Interesting. Open folder. Open file. I guess you can do it this way. It's a little more finicky, but it does the job. ADS is going to be blue. We're going to have another subject for CV, which is going to be yellow, yellowish, yellowish. Sounded racist, not gonna lie, okay. And Siri, I'm not even talking to you. Okay. CV. Not Siri, god damn it. Okay. What do I want? I want CS, not computer systems, cryptography and security. CS, and that was in like a deep red. And we're going to reorder these so that they make the most sense. Okay. Just gotta think. Just gotta think. Drink some water. Need some water. Okay. Let's just go on with this, right? Understand and revisit. Okay, same problem as Minsky's definition. What is thinking? What is mind? So the branch of computer science that is concerned with the automation of intelligent behavior. Luger and Stubblefield. Intelligent behavior. So what is intelligent behavior, right? Make good, rational action choices. Are humans rational agents? That brings up the question. A rational perspective, the branch of computer science that is concerned with the automation of intelligent behavior. Still the same thing. We often make mistakes. We are not all chess grandmasters, even though we may know all the rules of chess. So more about human systematic errors, Thinking Fast and Slow by Kahneman. So system 1 thinking and system 2 thinking. System 1 is automatic and system 2 is effortful. Deliberate and logical. Associative memory is system 1. Automatic associative memory. We got jumping to conclusions. Associative memory, so no idea, autopilot, stranger, jumping to conclusions. What do you see in all there is? What you see is all there is, right? Not sure. Alright. Rational agents perceive the environment through senses, percepts, act upon the environment through actuators. And some examples. Rational agents perceive the environment through senses, percepts, acts upon them through actuators, actions. Examples: human, animals, robots, software agents, softbots. Rational agents do the right thing. Any idea what that means, do the right thing? Well, rational agents select their actions so as to maximize a performance measure. What's the performance measure of an autonomous vacuum cleaner? Meter squared per hour, level of cleanliness, energy usage, etc. What if the vacuum cleaner sensors are not good enough? What if the vacuum cleaner's sensors are not good enough? Click. Robot revolution use. What the heck? They make it difficult, man. Okay, South Korea, woman's hair. You've chosen to reject third-party cookies while browsing our site. Clicking on reject all makes things trickier for us financially. A quarter of our income comes from advertising. Not being able to use third-party cookies means we are less for selling adverts to fund our journalism. We believe that access to trustworthy, factual information is in the public good, which is why we keep our website open to all, without a paywall. If you want to receive personal ads but would like to help, if you don't want to, you want to support us today, $20 per month. Never mind. Look at that. it's not mistaken and it's not as bad as you say it is, bro. It really isn't as bad as you say it is. Journalist. So journalist. Okay, try to do the right thing. The hypothetical best case, the right thing is often unattainable. Is this clickable? No. Okay, the agent might not be able to perceive all relevant information. Is there dirt under the bed? Rationality versus omniscience. Omniscience. An omniscient agent knows everything about the environment and knows the actual effects of its actions. A rational agent just makes the best of what it has at its disposal. Maximizing expected performance given its percepts and knowledge. Omniscience, rationality. Assuming everyone is rational and they're less omniscient. Right, an example would be I check the traffic before crossing the street. As I cross, I am hit by a meteorite. Was I lacking rationality? No, you are lacking omniscience. Map your input to the best possible output. Performance measure times percepts times the knowledge gives you the action. So what does AI do? Artificial intelligence as an idea can be roughly classified along the dimensions of thinking versus acting, humanly versus rationally, humanly, rationally, thinking, acting. So thinking humanly is systems that think like humans, cognitive science. Humanly acting, systems that act like humans. Rationally, systems that think rationally with thinking, and systems that act rationally. How to make good action choices. Thinking, acting, and humanly versus rationally. So humanly, so we're basically saying humans are not rational. You know, because thinking is distinct from acting. Humans are distinct from rationality. Give me a sec while I quickly check something with our home vacuum cleaner. There might be something up with it. Okay, what does AI do? Artificial intelligence is an idea that can be roughly classified along the dimensions, and a central aspect of intelligence, and one possible way to define it is the ability to act successfully in the world. Okay, here we go. This is where we actually had the lecture. The proposal of the meeting is processed on the basis of conjecture that every aspect of intelligence can in principle be so precisely defined that a machine can be made to simulate it. Damn. A few notable people. Talking about John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon. Theories and programs. For writing an AI dissertation in the 60s, 70s, and 80s, it is common to pick up a task and a domain X, analyze introspect to find out how task is solved, capture this reasoning in a program. The dissertation was then a theory about X, scientific discovery, circuit analysis, computational humor, story understanding, and a program implementing the theory tested over a few examples. Many great ideas came out of this work, but there was a problem. Lack of generality, limited scientific value, not successful so far. Sure. And the AI winter and formalization of AI techniques and increased use of mathematics. Yeah, but isn't machine learning the same as well? Problem solver solution. Jacobs. J equals 3p, J plus 10 equals 2p plus 10. Solve a Gauss-Jordan variable elimination. Damn, I didn't know there was an actual term for it. Gauss-Jordan. Solvers in general. So it's a solver example, right? Solver as general has deals with any problem expressed as an instance of model linear equations, however, is tractable. AI models are not. But what is SAT? Doesn't matter, maybe for now. AI solver, the basic model. Constraint satisfaction. Find state that satisfies constraints. Planning problems, find action sequences that produces desired state. Planning with feedback, find strategy for producing desired state. Solvers for these models are general. not tailored to specific instances. All of these models are intractable and some extremely powerful. The challenge is mainly computational, how to scale. For this, solvers must recognize and exploit structure of the problems, methodologies, empirical, benchmarks, and competitions. Significant is rare something. Can't read that. Can I highlight this? Significant progress in recent years, okay. Okay, SAT and SCP. CSP constraint. Satisfaction problems, maybe? Constraint satisfaction problems? SAT determines if there is a truth assignment that satisfies a set of clauses. So X or not Y or Z or not W or blah blah blah. Okay. Problem is NP complete, which in practice worst case behavior of SAT algorithms is exponential in number of variables. Yet current SAT solvers manage to solve problems with thousands of variables and clauses and use widely circuit. Design constraint satisfaction problems. Generalize SAT. Constraint satisfaction by accommodating non-Boolean values as well and constraints that are not clauses. By accommodating non-Boolean variables, that's interesting. Keys efficient poly-time inference in every node of search tree, unit resolution, conflict-based learning. Many other ideas logically possible but do not work, don't scale. Pure search, pure inference, etc. Classical planning model. Planning is the model-based approach to autonomous behavior. A system can be in one of many states. States assign values to a set of variables. It's a classical planning model. States values, set of variables, actions change the values of certain variables. So we're talking about constraints, and now we're talking about classical planning model. Planning is the model-based approach to autonomous behavior. Classical planning model. System can be in one of many states. State assign values to a set of variables. Changes the values of certain variables. Basic task, find action sequence to drive initial state into goal state. Complexity NP hard, exponential number of values. In worst case, planner is generic. It should work on any domain no matter what variables are about. Why do we need such an AI? Chess, 2-player, zero-sum game, music, speech recognition, recommender system, medical diagnosis. Decision support systems. I'm not sure that's how you spell decision. I'm not convinced. Self-driving car, playing Atari games, deep learning. What's this? Drug design, diagnosis, scientific discovery, robotic surgery, recommender system, search and retrieval, communication, security, user modeling, machine translation, echo computing, vehicle navigation, home robotics, autonomous space exploration, AI and preference, media and entertainment, ubiquitous computing, social computing, hello? What? Turing, Russell, Whitehead, Lovelace, Descartes, Aristotle. AI in music, AI in art, humanoid robots, augmented cognition, robotic guides and assertions, planning, AI and creative expression, plan recognition. Okay. Why do we need such AI planning? Setting where greater autonomy requires space exploration. I see. Business process management. First-person shooters. That is one thing that I'm interested in, which is if you do have a first-person shooter game, given so many variables that you have a mouse, you have a keyboard, you could build an aimbot that looks legit. AI and automated problem solving, a research engine that has emerged in the last 20 years. Solvers of a range of intractable models. Solvers, unlike other programs, are general as they do not target individual problems but families of problems. The challenge is computational. Consistent progress, effective inference models, tractability, transforms, compiling away. Okay. I'm going to have to understand these problems really in detail. What is it that I know? Alright. The contexts of AI. We have SAT. We have CSP. We have the general idea of AI. I want to try remember some stuff, right? Quizzes, where's the quiz at? Tell me that's the quiz. Let's do this quickly, I guess. How many comp graded assessment tasks? I think there's 4. Should you add to your calendar? Sure. mad. I must not post solutions. Of the assessment task on the discussion. Playlist of bite-sized lectures, 5 minutes each, will be published weekly in order to make the live lectures interactive. Even the tutorial will have a video to make sure you enter the session ready to learn. True. Being an active member of a discussion forum can help me and other students consolidate knowledge. I read the excellent form guidelines and I know how to participate. And besides teaching AI together, enjoy playing football, and we're runner-up of last year's Champions League. I'm gonna say true. Oh man. 5, man. We didn't make it to the Champions League, but we'll teach you how to do AI and educate. What, you're saying graded assessments including the exam? Yeah, valid. These are good, I guess. It's not happening. We're back. I think on Twitch side. Okay. We'll see how well it goes. How well it holds up. I think it should be fine. It's my IPv6, come on. Show me my IPv6. Not detected. Oh yeah. Just gonna do a speed test as well on the side. Block. I'm fine with that. Stuart Russell. It's been a while. That's normal, to be honest. Okay. Third edition. Alright, sure. Planning group. Mad.
90s and up to today, when you look at the main conferences and journals in AI, and even the classic book, AI, A Modern Approach, you will see that there is an increased use of mathematics, okay? And all the papers, all the areas, research areas, fall in one of those categories, okay? SAT and constraint programming, search and planning, probabilistic reasoning. By the way, the ones in blue are the areas that we're gonna cover in this subject, okay? So search and planning, we're gonna cover this topic in depth. Probabilistic reason, we don't have time to delve into that topic. Probabilistic planning, that's something that we're gonna cover quite a lot. Machine learning, okay, and when you look at probabilistic planning and machine learning, one very famous area that I think that everybody knows because it appears in lots of venues and a lot of even in the news, is reinforcement learning, okay, RL for short. RL belongs to the area of probabilistic planning because you technically take into account probability distributions about how the world works. You don't assume that you have a model about that probability distribution, so all these details are going to become clear later on. But it belongs both to probabilistic planning and machine learning because there is techniques, so the problem that reinforcement learning is solving belongs to the area of planning, but the tools used come from machine learning. Okay, so reinforcement learning always have been like a nexus between planning and learning. Then there is natural language processing, vision and robotics, and multi-agent systems. Okay, so the ones in blue are the ones that we're gonna cover in this course. Something that is common to all these areas is that they all could be understood as techniques used for AI problems, but I would say that it's more accurate and easier to understand if we think about them as models and solvers. Okay, so there is the search model, there is the planning model, there is machine learning model, and there is multi-agent model, and there are solvers to solve these models. Let me give you an example of what I'm trying to say here. Okay, so let's assume that we have a problem, okay? Generally a problem fits into a model, okay? So you've got a problem that can be expressed within a model, and this problem is fed to a solver that then gives you a solution. So let's see an example. Let's say that our model is a system of linear equations, okay? And the problem that we're gonna try to solve is the following. We know that the age of John is 3 times the age of Peter, and in 10 years, the age of John will be 2 times the age of Peter. How old are John and Peter? This problem can be expressed as the following linear equation. We've got John is equal to 3 times Peter, and in 10 years, the age of John will be 2 times the age of Peter in 10 years. So once we have the problem expressed in the model of linear equations, we can use something called Gauss-Jordan. Okay, so Gauss-Jordan, you might have learned it in your background studies. You might have learned about it as a simple technique to solve linear equations, but I want you to think about it as a solver, because it can solve any system of linear equations. Okay, so once you have a problem, the age of John and Peter, you express it in the model of linear equations, and you feed it to a solver. In this case, Gauss-Jordan. You can use any other solver that solves linear equations, and you will get a solution. Now, the interesting thing here is that the solver is general. Okay, it doesn't care about the problem that you're trying to encode. It only cares that you're gonna give him a system of linear equations. Okay, and the nice thing, at least, of linear equations is that it's tractable, meaning that it can be solved efficiently. Okay, so the size of the problem, with the more linear equations you have, the time that it will take you to solve it is not exponential. The problem in AI is that every model, or most of the models that represent interesting problems, they are intractable. Okay, meaning that you would need, in the worst case, exponential time to solve it. So looking at the categories that I showed before, what are the models in each of these categories? Okay, so I talked about constraint satisfaction and SAT, okay, Boolean satisfiability. In this course, we're not going to cover about constraint satisfaction and Boolean satisfiability, but I think it's interesting to know what they are. Okay, so in constraint satisfaction, you typically have finite state variables. Okay, so variables that can take a finite amount of values, and you have constraints specifying which values can be assigned to a variable depending on the values that you assign to another variable. To give you an example, if you think about the chessboard, there is a classic problem known the 8 queens problem, and you basically have to find out how to position all the queens in the chessboard in such a way that no queen can eat any other queen. Okay, and you can specify that problem in constraint satisfaction as a constraint satisfaction problem, and you can use solvers for constraint satisfaction to give you a solution, which is an assignment of each queen, for example, into which position of the board it should go. SAT is a subtype of problem of constraint satisfaction, if you wish. In SAT, you also have constraints over how the variables can be assigned their values, but the domains of the variables are only 0 or 1. Okay, so they are Boolean variables. There is certain benefit because the solvers and the type of inference that you can do, it's quite effective when you have SAT models and SAT solvers. But I will give some more details in the next slide, and that's it, at least for this course. Now, planning problems, which is something that we are very much concerned in this course. It's the problem of, let's say, you're given a set of actions and descriptions of the states of the world, and the solution should be a sequence of actions. Sometimes it can be a controller that produces a desired state, okay, from an initial configuration. And then you have something called planning with feedback, okay, that whenever you can sense or you have some feedback about the effects of your action, you actually can incorporate it into your state, and then solutions typically looks like policies or trees. Okay, so for every possible state that you might end up with, you should be able to say which action you should apply in order to reach desired configuration. So again, solvers for these models are general. They don't care at all about the semantics of the problem. Okay, so they don't know what are the meaning of the variables. They just care that you comply with the rules of the model. Again, all these models are intractable. Some are extremely powerful. Okay, so POMDPs, which stands for partially observable Markov decision processes, are really expressive. When I say expressive, it means that you can create problems that are very complex, and you can fit them in the model. To give you an example, some researchers in UCLA were working on an area called AI for social good or computational sustainability, and they were trying to solve the following. Okay, so they don't know what are the meaning of the variables. And in SAT, you also have constraints over how the variables can be assigned their values, but the domains of the variables are only 0 or 1. Okay, so they are Boolean variables. There is certain benefit because the solvers and the type of inference that you can do, it's quite effective when you have SAT models and SAT solvers. But I will give some more details in the next slide, and that's it, at least for this course. Now, planning problems, which is something that we are very much concerned in this course. It's the problem of, let's say, you're given a set of actions and descriptions of the states of the world, and the solution should be a sequence of actions. Sometimes it can be a controller that produces a desired state, okay, from an initial configuration. And then you have something called planning with feedback, okay, that whenever you can sense or you have some feedback about the effects of your action, you actually can incorporate it into your state. And then solutions typically looks like policies or trees, okay? So for every possible state that you might end up with, you should be able to say which action you should apply in order to reach a desired configuration. So again, solvers for these models are general. They don't care at all about the semantics of the problem, okay? So they don't know what are the meaning of the variables. They just care that you comply with the rules of the model. Again, all these models are intractable. Some are extremely powerful, okay? So POMDPs, which stands for Partially Observable Markov Decision Processes, are really expressive. When I say expressive, it means that you can create problems that are very complex and you can fit them in the model. To give you an example, some researchers in UCLA were working on an area called AI for social good or computational sustainability, partially observe rules of the model. Again, all these models are intractable. Some are extremely powerful, okay? So POMDPs, which stands for Partially Observable Markov Decision Processes, are really expressive. When I say expressive, it means that you can create problems that are very complex and you can fit them in the model. To give you an example, some researchers in UCLA were working on an area called AI for social good or computational sustainability, and they were trying to solve the following problem. They were looking at the problem of youth homelessness and HIV in Los Angeles, and they did a solver that told them which young people they should invite for information sessions in order to maximize the spread of information about how to take care of themselves and not get HIV. Okay, so basically it's the problem of choosing the sequence of people, young people in this case, that you should invite for information sessions in order to spread information. Okay, and that type of problem involves uncertainty on the state of the system, probability distributions about how likely is the information going to spread, etc. Okay, and this is just to give you an example of
How do you even know the
how
people?
expressive can some of these models be.
Like what parameters
So,
would you have of finding
as
people?
always, and I'm going
Or
to
choosing
repeat this
kids?
many times, the problem here is how to scale up, because all these models may end up requiring an exponential amount of time. And we all know, given that I know that you all studied a bit of algorithms and complexity, that when you have exponential problems, you very quickly hit the issue of not having a solution in an acceptable amount of time. So the main topic of how to scale up and the main effort of the research community falls into the category of recognizing and exploiting the structure of the problem. Okay? For this course, this means understanding the cause and effect from the actions or from the problems or the models that you have, and exploiting this information in order to narrow down or tame the beast of the exponential. Okay, so basically in order to be able to find a solution in an acceptable amount of time. If you wish, you could think about it as how intuition works. Okay, so our intuition, when we use intuition to guide our decisions, our intuition also recognizes and exploits the key components of a problem that we are trying to solve. Okay, generally the methodology to test how well a specific solver works for a specific model is empirical. There are standard benchmarks, so many families of problems that people have put forward and that fit a specific model, and they're standard, and they're used to actually compare different solvers. And there are international competitions that usually run every couple of years, where you basically get to compare how solvers perform over problems that the solvers have never seen before. Okay, so generally people make up new problems, and this is just to avoid people overfitting their solvers to existing families of problems. So this tackles the problem of generality in terms that the solvers should be able to cope with any problem that fits the model. So looking a little bit deeper into SAT and CSP. So typically the model in SAT, so Boolean satisfiability, that's what SAT stands for. It tries to determine a truth assignment. Okay, so truth assignment means trying to find whether a certain variable here, x, y, z, w, should be assigned a 1 or a 0, true or false. Okay, and this over here, it's called a clause, and typically you have many of such clauses. Okay, so you could have another one which states x or y. Okay, and you have to satisfy. Okay, this uses the standard notation of logic, so and ors and negations. Okay, so this type of model, it's called normal negated form. Okay, so this is the model used for such solvers. So each of those things are called clauses, and these are the variables. Okay, so SAT and CSP, they both are NP complete. Okay, so meaning that the algorithms in the worst case are exponential. Okay, so in order to find a solution in the worst case, the complexity is exponential on the number of variables. Okay, so imagine what it means. If you want to solve a problem with 100 variables, in the worst case you'll need 2 to the 100 times a number of combinations, or number of combinations that you should consider in order to find a solution. Now, you might recognize that this is an extremely large number. It doesn't fit in memory, but yet current SAT solvers, so state-of-the-art solvers, can cope with problems that have thousands of variables and almost hundreds of thousands of clauses, and they do actually work quite fast. So it is used quite widely in the area of verification. So for example, such solvers are used in airplanes when you want to verify if the logical circuit controlling some of the parts of the airplane are correct. You actually would model this with a such solver, or you wish that some of companies do that. And CSP, again, as before, the only difference is that variables are non-Boolean. Okay, so you can have finite domain variables, and the constraints can be a bit more expressive. Okay, instead of being just OR values. Okay, so these are ORs, logical ORs. Instead of being just logical ORs, they can be other type of expressions. Okay, I won't go into more detail. Now, the key thing here, at least, are two ingredients, and these two ingredients are pervasive to any model. Okay, so SAT, CSP, planning, machine learning, when we talk about reinforcement learning, and the key ingredients are search and inference. Okay, so what do I mean with inference? Inference is what I referred before as exploiting the structure of the problem. Intuition. Okay, so the key thing is that your intuition has to be efficient. Okay, so if your intuition is slow, well, maybe it won't help finding a solution. And the reason why we need the intuition or the inference to be effective and fast is because we want to use the intuition to guide our search algorithms. Okay, the classic inference methods in SAT are unit resolution, conflict-based learning, etc. Many other ideas are possible, and this is very much an active area of research. When we look at planning, okay, so planning, it's the core area that we're gonna study in this subject. It talks about autonomous systems, and specifically about discrete systems, okay, so we're not going to talk about continuous dynamics here. So planning is the model-based approach to autonomous behavior. Okay, so typically a system can be in one of many states, and a state is described through a set of variables, and the variables can be assigned a set of values. Okay, so to give you an example, we can think about the problem of me giving this tutorial or this video, and I can describe my surrounding as the variables being where my laptop is located, where my screen is located, where is my microphone located, and the assignment of those variables are basically their locations. Okay, so I have a state variable for the computer, a state variable for the microphone, a state variable for the camera, and their locations could be the possible values. Okay, then one state is basically an assignment. Okay, so where is each of these variables located? At least in this example I'm giving you, where is my laptop, where is my microphone, where is my camera? So once you have a state that describes basically the state of the system that you care about, you typically have an initial configuration and you have a desired goal configuration. Okay, and the way to go from an initial configuration to a goal configuration is through a sequence of actions that perform transformations over the state. Okay, so you start with the initial state and you want to find a sequence of actions that would bring this state closer and finally reaching the goal. Okay, so what are the main ingredients again of a classical planning model? You've got state variables, you've got actions that change the value of those state variables, you've got an initial state, and you've got a goal state. So this would define a model that you would fit into a planner. Planner is the same as a solver. It's just like the specific name that we give in AI planning. So a solver is basically a planner that, given a model that is the problem that we care about, it will tell you which is the action sequence that you should perform in order to transform the initial state into the goal state. Now, the complexity of this problem is harder than SAT and CSP. Is NP hard, actually is P-space complete, to be more specific. So we also need to learn about some search techniques that are effective and some inference methods that are effective in order to scale. Okay, and again, remember, this is like Gauss elimination. Planners don't know anything about the meaning of the variables, the meaning of the actions. Okay, they just care that you give it a planning model. Okay, so why do we need such an AI, let's say, such a model, like planning problems that are useful or are interesting in AI? Okay, so I will just bring some applications here, some interesting applications that are very much related to AI, planning, and other areas as well. Okay, so the first one that comes to mind is chess. Okay, we all, at least I remember, when Kasparov was playing against IBM and he lost the game, and basically it was the first time that a fairly complex task that we all thought that AI couldn't beat humans. Well, AI could beat humans, and that's a type of problem that implies a sequence of actions transforming the initial configuration of the board to a desired configuration, which is basically a winning game. Okay, this is a classic two-player zero-sum game, so it's a specific type of planning problem, but still it fits the category of planning problem. We have the example nowadays of Go and other type of board games. Now, why do we care about board games? Okay, so you might ask, why is that important? Or why even like people have looked at it since the very beginning of AI? The main reason is that board games are are, let's say, predictable, meaning that whenever you do an action, the effects of that action will always occur. Okay, so that in the lingo it's deterministic, meaning that you do something and you will always have the same outcome, or at least the one that your model had encoded. It also gives you certain advantage, like you are omnipresent and omniscient. You know everything about the state of the environment. You can see the chessboard, so that's something that's quite handy. If you think about some other games that you could try to throw into this category, for example, poker. Poker is more challenging than chess and Go, because you don't have full information about the state of the system. Okay, your other players, you don't know their cards. Okay, so board games have certain assumptions, which is full observability. The actions are deterministic, that basically are quite good to test how much we can actually scale up and to challenge existing solvers. Then we have music and speech recognition. I imagine that you might know an app called Shazam. It's an app that I use quite a lot. Sometimes I hear a song in the radio and I don't know what's the song, and I just click on Shazam and it will listen to the song for a few seconds and it will tell me the name of the song. So that problem, it's a type of problem that it uses certain things from planning. So basically, the way it works is that for every song, you need to build a probabilistic model of the song. Typically, you do it with a hidden Markov model. And when you have a signal coming, you run all the models for each song that you know about, and you try to find which model predicts best or explains best the signal that you're just listening. Okay, and you do this with Viterbi, so you use a search algorithm, you use some sequential decision models, which is hidden Markov models, and the outcome here is not to be able to transform a state into a desired state, but actually to do it for prediction. Okay, so this is just to show you that you can always use common techniques in different type of areas. Recommender systems, I imagine that everybody knows about recommender systems. You can always think of those also as a planning problem, which is the sequence of items that you want to recommend to someone. Medical diagnosis, decision support systems. This started with the expert systems, but also medical diagnosis is not a one. I mean, it can be a single-step problem, just diagnosing a disease. But if you want to do treatments, for example, it requires planning, because it requires to think about the sequence of treatments that you have to do in order to make someone healthy. Another area that is very important for planning is self-driving cars. Obviously, there is a lot of attention now in the sensors, which rely on machine learning algorithms in order to do the detection of the cameras and the surrounding of the car, but the actual steering, which incorporates low-level control and then continuous dynamics. But when you look at the path planning, so the higher-level discrete steps that has to be done, this actually uses classic search algorithms that are quite common in planning. Okay? And then there are other problems that also have been in the news quite a lot, which is playing Atari games, so playing any game that can be handled with a simulator. This is very similar to the same motivation of chess. Okay, so there are very controlled environments. Okay, the advantage of having a game console is that you have a family of problems that can be played. Okay, and also this has been shown that deep learning can work very well, but also very simple planning techniques can work as well and better than deep learning techniques. This poster was released in 2011 by the Association for Advancement of AI. Okay, before was the American Association, but this is one of the main conferences of AI, and I think it's quite interesting. I encourage you to actually zoom in, have a look at the type of applications that at least in 2011 they were actually highlighting as interesting problems. And here you can see, for example, planning in RoboSoccer. Okay, so it's a competition that still goes on. And I won't go into the details, but I encourage you to actually look around, because it might inspire you into areas that you might find an interest and that you might want to deepen your knowledge. In terms of planning, more specifically planning, okay, so where planning has been shining for quite a lot of time. So the first great success of planning was in space exploration. Okay, so NASA launched a spacecraft in '98 that was controlled by a planner. Okay, so I'm not talking I'm not talking about the low-level control, continuous dynamics. I'm not talking about those. I'm talking about the sequence of tasks that have to be done in order to actually pilot a spacecraft. Okay, and for the first time, NASA showed that they could use planners to do autopilot in space, and planning has been used since quite a lot, and NASA has a quite important lab on planning. Business process management, this is an area that analyzes what are the processes that have to be followed by certain businesses. I won't go into details, but there is quite an important group in Melbourne Uni doing research on that area, and there's a lot of connections between planning and business process management. Games, okay, specifically first-person shooters. Okay, so maybe some of you know about a game called Fear. Fear was a game, I think, from the early 2000s, and it's by experts. They say that it's one of the best games in terms of AI, and you won't believe the simplicity of the AI planner that they use. Okay, so the AI planner that they use is just a planner from the 70s. Okay, so a game that used a planner from the 70s is nowadays what became, let's say, a classic example of interesting AI in games. Because generally games, their AI is more scripted, and so using a planner has a lot of potential to disrupt in the game industry. Interactive storytelling, Disney, for example, might be really interested in this, and other applications, for example, in chatbots. So think about it as, instead of writing a script, you write the model, the classical planning model, specifying which are the actors, what are their possible actions in the world, and you give them objectives, okay? And you let the planner come up with actions that form a story, okay? So you could think about it as goal-oriented storytelling without actually saying which are the set of steps that each character takes. You let the planner come up with those stories. Network security, the industry uses something called penetration testing, which is they use planners in order to hack networks. Okay, so typically, if you are a company that you want to understand what are the possible issues that you have in your network, you could use a planner to try to find the sequence of actions in order to hack your network. Okay, so that area of penetration testing planning is used in the industry. Logistics, transportation, manufacturing, this is something that is quite pervasive. Xerox PARC, it's one of the biggest AI labs in the world. It invented, for example, things that are not from AI, for example, the mouse was invented there. But for AI, they've been quite important, and they're famous for their massive printers, and that printing is also a sequential decision-making problem. Okay, so all these problems have in common that they're sequential decision problems. So you need a sequence of actions to achieve a certain configuration. Warehouse automation, the type of problem that I'm trying to convey here, it falls into a category of multi-agent pathfinding. Okay, and I think that if you looked, or if you know what the Post in China has done, or Amazon warehouse, what they do in the warehouses, they actually automated all their shelves pretty much. So the shelves move around, and I'm gonna share some videos. So by the way, all these blue keywords, they are links. So you could click on the slides and we will pop up some links. I'm also going to put the links in Canvas, so you can look at them. Then, for example, this Slumberg, they do large exploration and for example, extraction of oil or other such industry that kind of fall into logistics, but also manipulating large robotic platforms also can be done through through planning. And here the last link that I leave over here is ICAPS in action. Again, I'll put all the links in Canvas so you can explore at your own pace. Okay, so just to summarize this first bit of videos. In the last year, a research agenda had emerged which talks about solvers and models, specifically intractable models, okay, meaning that it's hard to solve them. The advantage with respect to the 70s are that these solvers are general, meaning that they can solve any problem that can be expressed in the model. That's why we talk about family of problems. The challenge now is computational, basically how to scale up. We still, given the challenge that exists, computational challenge, we can still scale up quite well and have meaningful solutions. The way that we go about it is by exploiting the structure, and again, think about it as you formalizing or trying to convey how intuition can be gathered from the models. And the way to assess every idea is empirical. Okay, so there's consistent progress in areas of how to do inference. Okay, so deriving new heuristics, new conflict learning approaches, detecting islands of tractability. Okay, so if I make extra assumptions on the model, so I limit the type of problems that I can deal with, maybe my model will become tractable. Okay, so if you know about pathfinding, okay, so the typical problem of pathfinding is find a path in a grid, for example, from A to B. That problem is polynomial. Okay, so maybe there are certain planning problems that can fall in that category. And another thing is transformations. Okay, so basically you compile away, so you forget about certain aspects of the problem, in the hope that it will help you find a solution. In this video, we're gonna learn the basic ingredient in order to build an AI solver, which is
Alright, so that's one set of lecture slides done. We will need to further go through all of these lecture slides. And anything which I don't understand, I'll keep an eye on closer. The thing that I need to also remember let's have a look at some of these links. Autonomous spacecraft. Damn, this is like the epitome of AI application. It's the same thing. Oh, right. Multi-agent pathfinding. I've seen these before.
Hello everyone, I'm a sorting robot. I know I look cute, but my skills are a lot more impressive. I can identify the information on each of the parcels effectively and sort them out precisely. My friends and I can process as many as 18,000 parcels in an hour.
This is a 1.3 square kilometer transit warehouse. The use of sorting robots improves efficiency, accuracy, and security during the sorting process, and also reduces manual labor costs by an astonishing 70%. This AI and logistics model is now revolutionizing the express delivery industry across the country. Between 2012 and 2016, online retail sales in China skyrocketed from 1.3 trillion to 5.2 trillion yuan, making the country the world's largest online retailer. With a flourishing development of online shopping, the express business is also booming. There are now around 8,000 express delivery companies in China and more than 2 million people working in the logistics industry. Last year, more than 31.28 billion parcels were delivered in the country, accounting for 40% of the world's total. Revenue from the express business has reached 400 billion yuan, while the per capita usage in China was approximately 23 deliveries per year. With the recent rise of AI and big data, the concept of smart logistics has been put into service. Drones and unmanned vehicles are delivering items faster than ever before as China's logistics sector prepares to enter.
How long ago was this? 6 years ago. Okay. 6 years ago. And yet I still see LinkedIn posts similar to these.
This is
5 years ago.
the robot highway. These are my babies. Our entire operation depends on these. I started at Amazon just looking for a part-time job, just manually scanning boxes to pallets, and my senior leadership approached us and they said, hey, this is the project that's coming in, this is the job opportunity we have, start thinking about it. And now I get to play with robots all day. An associate will place the package on the robot knows exactly where to drop it. Each of those little chutes is a specified destination at the bottom. So a big part of my job is monitoring the activity and the traffic patterns. I'm looking for any major congestion spots. I'm looking for any robot that isn't functioning the way that it should. We've gotten a lot of on-the-job learning with regards to how these things work, how the programming works, because I had no background in robotics at all. Just having the opportunity to be a trailblazer is just absolutely phenomenal to me. I tell my family that I babysit 800 robots. I wouldn't have my job without these robots. And now when I walk in, it's kind of like, yeah, this is Amazon. It's like, this is what I do.
5 years ago, people were cringe. I'm not gonna lie. Okay. Cool. And we can read all this. I want to save this though. Is this saved already? No. Okay, I'll be reading this in detail as well. And although, yeah, we're going to put these in the right places as well, I'm going to have to make a shortcut. Open a new window. Nope. Okay. I'm going to make a shortcut to this folder. Pin to start. No. Maybe I can just drag this. Can I just drag this? Okay, pinned to File Explorer. Pinned to Quick Access. Did that even work? It did. There's nothing there. How do we unpin this? Unpin. Slides pre-handout. I am confused about the naming, but we'll leave it as is. And resources. We can call this an actual name. Model free, model based in general intelligence. Properties, change to Firefox, apply. Okay. Rename. Okay. We can read up on this after we've done some of this. I'll keep this open, close this one, and we've seen all that we needed. Pre-handout for search. Next week we'll include a post handout with embedded answers to questions discussed in the video and worked examples if applicable. Like I kind of get what you mean there. I kind of get it. But let's see, how many more is there? So no, it's just these two. So it's 16 minutes of reading. Watching. I'll probably do this after, but right now I'll get onto a Leetcode question. So we'll pause this for now. And I'll just reopen this, see if it works. It does. Alright, yeah. Yeah, it does, okay. Okay. See what we can do here. Find the duplicate number. What happened to the WSL? It's a good question. This problem can be solved using a hash set, but if you want an O of 1 extra space solution, it's going to be a little bit different. So can you solve the problem without modifying the array nums and using O of 1 extra space? Now here's the thing, right? Let me do the solution with the O of n extra space. And this is just a normal list. I don't see how this becomes a linked list problem, right? Find the duplicate number. It's not necessarily a linked list problem, no. It's just a list of integers. Alright, well, now to solve it in a O of 1 extra space, maybe you need 2 pointers somehow. Possibly. 2 pointers. Maybe you have a left and right pointer, right? Maybe you have a left, you got an R starting at 0. Maybe a while. So you're not going to have a set anymore. You're not going to have this anymore. You might use a while loop where L is less than R. But that's not necessarily the case. It still has to be linked list. It still has to be a linked list problem. Am I going to have to define my own linked list structure? Yeah, let's have a look. Fast and slow pointers and singly linked lists. I feel like you could have done it with fast and slow, right? As well. Oh bro, where's the sideberry config part of the stream? Good question. I'm already past that, but we already did it. We did it yesterday. Did it as much as possible. Got it as optimized as possible. So I think I'm happy. I'm happy with leaving it as is. I know you probably subscribed for the for the sideberry config. Slow and fast. How are you doing the sync between computers? Good question. I'll tell you. So right now it's just got to be bookmarks. So, you know, it's still a bit of a process, but I'm thinking of it like commits now almost, you know. As soon as you're done with a set of tabs, you commit all the tabs to bookmarks. So you would save to bookmarks, for example, and then they'll be saved to a specific bookmarks folder in on Firefox. And then the idea is you'll sync it onto the other computer, your bookmarks, and then you can restore from bookmarks by, if say I was on this computer now, this other computer that I had, and I was to open up CS, I would open that up, I have nothing in my tabs, and then I would just restore from bookmarks. And that's a good idea. Does it save the hierarchy of the tabs too? Yes, from what I've seen. So right now I just have one of these tabs. This was kind of like a small hierarchy. I can close all the tabs here. Let me close all the tabs there. If I go to APA again, reopen this tab, it currently has nothing. But then if I restore from bookmarks, it restores from that specific tab session, and it'll it restores from those specific set of bookmarks in the bookmarks section. So if you look in the bookmarks section, you know, it'll be in your other bookmarks. So it starts off in other bookmarks, APA, and then I don't know what's happened here. I mean, it's kind of weird, but yeah, like it's still in a subfolder of itself, so it keeps the structure from within the bookmarks tabs. So that's kind of good, you know, using the internal bookmark foldering structure to help with the rest of the tree structure maintenance. So that's good. But yeah, apart from that, I think I'm happy with this. I'm just going to use it as is for now. But in the future, like after I've finished creating this scheduler app that I'm building currently, I really want to consider creating my own bookmarks manager. I don't know if I cut out there before. Hopefully I didn't, because the wind is winding in my house and it blocks the internet sometimes. I saw the bars go to 0 for a second. Hopefully you heard what I said. But yeah, in the future, there is a plan, and I'm willing to do it, to build a tabs manager. Alright, good. Didn't cut out. Awesome. Yeah. So I'm willing to build a tabs manager in the future after I've done this scheduler app as well. And it'll be a lot of things to maintain and do well. There's a lot of looking into things, and I guess that's just part of the process, right? And I'll find some people to work with as well, at some point, who are equally as hyped for the solution. A lot of things to maintain, a lot of fun. That's it. And I won't feel depressed in my life no more. Not that I am, but you know, when you have a meaning in life, you know, it's the meaning that drives you, and you make that meaning. Anyway. Oh, and a good thing about Sideberry that I saw is, you know, it keeps these tabs isolated. So if I change to another panel, it'll also just open those 4 sets of tabs on the top bar and then hide the other 2 that are in the background. And then I can just close it with a middle click to unload the tabs, and then they disappear. And then I'm just like in a different workspace. Epic stuff. How come this question is Floyd cycle detection again? Maybe this was the precursor to the question. This was the reason for the other question being made, the linked list cycle question, which makes sense. But why? I altered my Firefox setting to hide the top bar, but that also hides the window controls. Oh wow. Yeah, okay. I also saw you could do that. Good luck with Leetcode. Anyways, enough side, very good luck. Yeah. I mean, thank you. Thank you. It's all good. I'm gonna probably not even finish this Leetcode question and go to the gym for a bit. We'll see. It might be quick though.
Hey everyone.
Oh, it's a 17-minute video. Am I willing? Am I willing? I might be... It means that if I do this question, I'm definitely going to eat lunch. And then it'll mean that when I finish lunch, I go to the gym. But usually there's a mid-afternoon energy dip that I'll face. Ugh. But if I go to the gym now, come back, do this question, I'll be primed to do some more study after doing this question. Then I'll finish the study that I need to. I'll do the scheduler. Although I feel like maybe I should just do the scheduler after the Leetcode directly straight away. I'll think about it at the gym. I think I will go to the gym now. It is 1 p.m. Where I live. But we're gonna have lunch late today, I think. Alright. I think I'll be back in a bit. I'll keep the music playing and the wind will keep blowing.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve find the duplicate number. And you can see that I'm not really a big fan of this problem, and maybe I'm just salty, but I really feel like this type of problem is the ultimate test of whether you've seen the problem or not. But I'm still solving it nonetheless because it's an interesting problem and it does show up in interviews quite a lot, it seems. I really don't know how anyone would be able to solve this problem in a 30-minute interview without having seen it. Even the person who came up with the algorithm, Floyd, I doubt even he could solve this in 30 minutes in an interview setting. But that's okay, let's just learn the problem today. So we're given an integer array of nums containing n plus 1 integers. This is the length of the array, but every single value in the array is going to be within the range 1 through n. So we have n different values that could be in the array, like n different choices for the integers, but we have n plus 1 integers. So that kind of implies that at least one of the numbers is going to be repeated, and they tell us that actually it's only one number is guaranteed to be repeated. And the only thing we want to do is return the number that is repeated more than once. Now, the easy way to solve this problem, of course, would just be have a hash set, right? Iterate through every single value, find the one that occurs twice. By using our hash set, that's going to be O of n time and O of n memory, but they tell us that we can only use constant extra space, and we can't even modify the input array, so we can't even sort it or anything. And I think those restrictions probably make this a hard problem rather than a medium problem, but that's okay. So there's two aspects to this problem, and I'm going to explain both of them. So we're going to solve this in O of n time and O of 1 space. The first thing to recognize is this is a linked list problem, specifically a linked list cycle problem. And the second thing is to know Floyd's algorithm, which will tell you the beginning of a cycle in a linked list. So there's two problems: one, to even recognize that this is a linked list problem, and two, to know the algorithm to actually apply to it once you know that. So let me actually show you how we can figure out both of these things. And yeah, you're right, it's probably not super intuitive, and I'm not really sure how you would be able to figure it out on your own if you've never done something like this before. So remember that the length of our array is n plus 1, but every value in the array is going to be between 1 and n. So there's n different values, but there's n plus 1 positions. So in this array, we have 5 different elements, right? And we know that the elements are going to be in the range 1 through 4, right? So basically, if instead of thinking of these as values, let's think of them as pointers. So we know for sure that every single value in the array is going to be in the range 1 through 4. That means if we considered every value as a pointer, each value Floyd's algorithm, which will tell you the beginning of a cycle in a linked list. So there's two problems: one, to even recognize that this is a linked list problem, and two, to know the algorithm to actually apply to it once you know that. So let me actually show you how we can figure out both of these things. And yeah, you're right, it's probably not super intuitive, and I'm not really sure how you would be able to figure it out on your own if you've never done something like this before. So remember that the length of our array is n plus 1, but every value in the array is going to be between 1 and n. So there's n different values, but there's n plus 1 positions. So in this array, we have 5 different elements, right? And we know that the elements are going to be in the range 1 through 4, right? So basically, if instead of thinking of these as values, let's think of them as pointers. So we know for sure that every single value in the array is going to be in the range 1 through 4. That means if we considered every value as a pointer, each value is going to point at some position in this block of 4. You can see that this one points at position 1, this 3 points at position 3, this 2 points at position 2 over here, and this 4 points at position 4 over here, and then this 2 points back at position 4. So that's how you can kind of see that, you know, in that case there was a cycle, and you can see I basically drew out the linked list version of that. So it's not hard to see that this portion is going to form a cycle, because no matter what value we look at, it's going to point at some other value inside of this range. There's never going to be an exit condition. None of these values are going to point outside of the range, either, you know, over here or over here. None of them are going to point outside of the range. So this portion is going to form a cycle linked list somewhere, right? What about this value? Is this going to be a part of the cycle? Notice how none of these values, nothing is ever going to point at index 0, because remember, our range is between 1 through 4. None of them is going to be 0, so none of them is going to point here. So we can guarantee that this is not going to be a part of the cycle. And when you see, I took this array, drew it as a linked list.
KFC says hello. Hello to you too. I'm trying to learn this specific problem.
Start at the beginning, it's going to traverse this P portion, and then it's going to traverse this C minus X portion, and it's going to land at the intersection point, right? Now we know that the fast pointer is going to do more than that. It's going to, of course, do this P portion once, then it's going to do a complete loop, right? Because remember, the fast pointer is going to out-loop the slow pointer, and it's going to overlap. But it could be anywhere. So let's write that mathematical equation out. So we know that 2 times the number of iterations the slow pointer does is equal to the number of iterations the fast pointer does, right? How many spaces it moves versus how many spaces the slow pointer moves. Of course, the fast one is twice as fast. That's why we have to multiply the slow one by 2 to make it equal to this one. And how many iterations did we say that the fast one does? It's going to do P plus CX, right, to get to this position, and then it's going to do another complete cycle starting from here to get back to this position, right? So it's the fast pointer is going to be P plus C minus X plus C again. So more simplified, it's going to be P plus 2C minus X. The slow pointer is just going to do P, and then it's just going to do C minus X. So we'll have a 2 on the outside, P plus C minus X. So I'm going to take this equation and simplify it over here to the right. So once we simplify it a little bit, we're going to get 2P plus 2C minus 2X, which is equal to P plus 2C minus X. And then this is the part where you can start doing a little bit of algebra. So we can cross out the 2C from both sides of the equation. We can cross out 1x from each side of the equation. And we can cross out 1p from each side of the equation. Once we do that algebra, we're left with the equation, and sorry that it's getting a little bit messy, we're left with a single p and a single negative x. So we get p minus x is equal to, notice how we crossed out everything on the right side. So we got p minus x is equal to 0. When we rearrange that, we get p is equal to 0. What did we just prove? We just proved that the pre-portion of the cycle is always equal to this, right? So that's how we know once we have a pointer over here, then we can set another slow pointer over here, keep iterating them by 1, and for sure when they meet, they're going to meet at the start of the cycle. They're always going to meet at this position. So I hope this explains a little bit of the intuition and a little bit of how, this is very rigorous. This is a proof. This is always going to work. And now you know why it's always going to work, but the code is actually really simple. Now, one last thing I didn't mention before we dive into the code is that notice how this pre portion could be really long. It could be even longer than the entire length of the cycle. So how would that update our math? Would our math still work out in that case? And I didn't include this in the math because I don't want to overcomplicate it too much, but yes, the math would work. Instead of having 2c over here, we would have an n over here, and the math would end up still working out. Basically, we would always start back at the beginning here. We'd traverse this many nodes, and then from here, basically, instead of just traveling this small distance, it could be possible that we would have to do multiple loops, because if this distance was really long, longer than the length of this loop, we would have to do multiple loops. But after all of that, the remainder would still be this portion left. So we would still end up getting to this position, the start of the loop. Okay, now we can finally get into the code. So remember, we're going to be starting at phase 1 of this algorithm. We're going to have 2 pointers, fast and slow. They're always going to start at 0, remember, because we know 0 is not a part of the cycle. That's for sure. And we're going to keep iterating through these loops. I think there's an easier way to write this code, but I'm lazy. So just while true, we're going to, and we start out with while true because we want to keep going until they intersect, but notice how they already intersect at the beginning. So we're going to update slow. So basically, slow is going to be
num slow. I think num slow is going to point to the first position, 2, and fast is going to point to nums. I'm guessing nums num of slow. Can you even see who's in the back? Don't worry about it. Slow. Okay. Nums slow. And if fast equals slow, then a third pointer I equals 0 maybe, and slow ooh. Equals nums slow if I equals slow I equals nums I equals slow you know when it starts, but what's the point of this? So you want to find the number that repeats, right? Because it's a cycle. Return I. Return I. Return slow. Infinite loop. Valid. If fast equals slow. I equals 0. If I equals slow, is that what I want? I'm thinking about it from a linked list point of view, but these are indices. While true, if fast equals slow, okay. I'm just trying to see. I'm slow, fast. Right, break instead, and then move all of these sideways. Damn. Is there a do while loop for Python? Yeah, sure. Slow is equal to nums slow. Fast is equal to nums of nums. Use ChatGPT, bro. It's a good point. I've used it a lot already. Don't want to use it for Leetcode, you know what I mean? You'd be brave to use Leetcode in ChatGPT in an interview. Heh. So, what was it here? If slow is equal to fast. Now, like the basic stuff, if you're forgetting something. Yeah, true. That's true. But even with that much of a basic stuff, I feel like going to documentation would also be good. You know? Like, either way. But yeah, like, actually I do use ChatGPT for a lot of the quite a few like data science stuff as well. If I'm using specific libraries, it's a good way to find the specific functions that I need to manipulate the data. So I do use that a lot for that. So we said if slow, fast, then we're braking, and the result is the number. Yeah, this is, I wouldn't have even realized this is linked list cycle type question. Yep, fair enough. Shift G, yank. Now go to the actual Leetcode problem. Paste it. So after Control All V, submit. Clear if so git add get status git commit. What question was this? Question 287. I'm new to Leetcode. I did 2 binary search questions today. Epic. Well done, man. I was doing binary search not long ago anyway. As well. Are you also following Neetcode or just doing Leetcode directly? Gonna get some water, be right back. Right now, just Leetcode after finishing all the DSA theory. I will do Neetcode 150 questions. Yeah, epic. Just Leetcode after finishing all the DSA theory. Damn. So, you're actually doing all of that. Are you then, I'm guessing, like, in your first or second year, currently, of uni? If you're going to uni? Because I just skipped all the theory, pretty much, because I learnt it from uni already. Yeah, I'm going to second year next month. Yeah, good man. Hey, what you're doing now is way beyond what I've... is way beyond how much I did in second year or first year. I'm doing catch up. Just gotta see the size of the chat for a second. Okay. Don't worry about it. Don't worry about it. Okay. Now, should I do LRU cache? It's almost 5. I'm gonna just do a little bit more study now, I reckon. One question is better than none question. For Leetcode, that is. So I'm gonna call it a day for Leetcode. And just go back to a little bit more study, which is going to take some maybe like an hour or two. So yeah, let's see. Unavailable URL. That's sad. I would expect it to work. Why wouldn't it work? Let's see, API resources, model free. I don't see why it would work. Just gotta reopen it. That's just something like I just gotta reopen. Okay. Same for this. Okay, but fair enough. This is located not in the folder. Okay, if I close these right now, will I be fine? And then open them up again. These show up. Codecademy free course for learning a bit of Python. That's kind of cool. You can learn Python 3 just for fun. Don't need it though. I'm pretty good. KFC says, I'm thinking to switch completely to Linux, currently using WSL. What do you say? Depends on your use case. Definitely would say that I think I prefer Linux over Windows 100%, but right now I'm using a Windows computer. The only reason I'm doing that is because I am streaming. It's just way better of an experience streaming on Windows. On Linux, if you wanted to stream, it's actually a lot of headache, and just trying to fix things or like get things the right way. And I'm talking about dual booting Linux right now. So, you know, you're using the same hardware. And even with using the same hardware, it's still more performant to run OBS on Windows. All right, so that's the only reason that I would go for Windows. Otherwise, you know, in terms of programming, like 100% go for Linux or Unix-based systems. You know, in my first or second year, third year, I've been using my Mac. I'm still using it right now. You know, I got it on the side here. So that's my Mac here. And that's Unix-based. You know, every command that I type that's like Linux, it's pretty much just Linux, right? It's Unix. And so I would say still, if you're looking to be a developer, have some Unix-based system. That being buying a Windows computer and then dual booting it to Linux, or just making it completely windowless and then just going Linux straight up. I'd give you like so much credit if you just go Linux from the get-go. And I'd give you even more credit if you go for Arch Linux. Right, I think everyone's heard of Arch Linux. Right, so that's the specific operating system or flavor of Linux that I'm planning on going to eventually. Right, and you know, I would say a Mac is good if you want to get an introduction to Linux, although it's not really Linux. You know, it's Mac OS. And Mac has its own pet peeves of mine as well. That's just so random that it doesn't exist as an operating system level feature. Because, for example, you know, window snapping is not a feature of Mac OS. You have to buy, or you have to get external extensions, third-party extensions that does that functionality for you, and that you can like get from any basic Linux distro now. And Mac OS doesn't have that, which is just way too quirky for me. I'm pretty sure in the next release they're going to have a window snapping feature, but even then that window snapping feature is still not perfect, because right now this Mac that I'm holding right now has the beta version of Mac OS, of the next Mac OS release, and the window snapping, the native one that I am using, not good at all, I would say. Well, it's good enough. It's good enough, but it's not as good as the third-party version. So I would say, you know, they still haven't succeeded in that respect. Yeah, I could talk about this for ages, but basically, go for Linux if you can. Don't go for Mac if you don't have the money. And if you do go for Linux, like, you're gonna be balls deep. Just expect that. Mac, you can get away with convenience a little bit. Although, you know, the quirks of it is pretty sad. Okay. All right. So the plan is, I've looked at I got to look at these last two lectures. Just got to see where they get up to though.
Local and for optimal planning.
What works where? So what works where in planning? Okay. Okay, it goes to here. Okay, for 13 minutes, it goes to what works where for planning and search terminology. Agenda. Where's agenda? Blind systematic search heuristic functions inform systematic search. Local search, what works where in planning. Search terminology. There's more to come, but it'll be in person. So the thing is, I could learn as much of this as I can, or look through as much of this as I can while I write it down. Put question marks where I need to, come back to it to further understand. And the biggest things that I need is practice. I just need practice on these types of questions as well. Okay, well, regardless, let's have a look through these. Alright, that's the thing. So this lecturer also mentions what was the word he said? Solver. He called it a solver, right? This to call it a solver is actually pretty specific, or there's a full definition to what a solver is. And right now I need a way to just let me just split it in thirds maybe. Okay. If you hear anything in the background, expect it. Shift N, not even. Okay, I'm gonna go quiet for a bit. Bro, are you making notes or what? Question mark, question mark. What's the name of the app you're using? It's called Obsidian. And yes, I'm going to write more notes. You calling me out is good. Thanks for calling me out. I'm not joking. I gotta write more notes. More importantly, I gotta write more questions. But I just want to set out, you know, a good structure to my page so I can write the questions in a way that I can easily reference back where I got that information from. You know what I mean? It's a bit of maybe it's a little too much, depending. We'll have to see. That's cool, man. I'm going to use the app. Okay, epic. Glad I got someone to use the app, you know? Yeah. It's called Obsidian. There's going to be a little bit of finicking around, I will say, so just be prepared. I usually make notes in blog. Blog as in like a website blog? Or something else? think. The wind took the internet out again. But yep. I'm Savaske. Ooh, logseek obsidian doesn't feel right for you? It's a good question. It's a very good question. I'm using it right now for this, but the problem is I want to be able to annotate my PDFs, and that seems to be a functionality of logseek. And you know, every other I guess marketing strategy, every other what's it called, feature seems pretty nice as well. But we'll see. You know, maybe I got to give logseek a go. You know, we'll see. Logsec is a lot different from Obsidian and other Note apps, so I'd recommend looking at how people use it to get a good understanding. Yeah, it's a good point. We'll have to see, because I'm still going to be iffy. We'll have to watch some videos in my spare time, I think, to fully understand this. But, you know, I'm trying to kind of rewrite my notes here. See what it's like. Is there even a way to tab inward? Ooh, I don't know if this is a bug or not. Look at this. Oh, maybe it's because I just need to add a new folder. It's block based, so each bullet point can be its own node page. Interesting. Mad, I see. I'm gonna try creating a new thing. So Command K. Whoops. First off. Here's the thing, Savasco. What do you use? Do you use a little bit of both? Or one or the other? Obsidian or Logsec? I used to use Logsec, but it kept crashing, so now I use Craft. Interesting, so there's even more. Obsidian didn't work well after experiencing Logsec. Fair enough. I'm guessing that didn't work well in terms of your, I guess, work style. Vim-like operating feeling. Possibly. Yeah, and I prefer the outliner bullet pointer style note-taking of logsec compared to Obsidian, which I feel forces you to write more paragraphy. Yeah. I definitely can see the difference here. And I mean, look at me, right? In Notion, I'm trying to write in bullet points most of the time. And feel like Obsidian is more targeted toward people who just want to write blocks of notes, right? You know, for their research, for example. And that would be perfectly fine for them, but for me also, if you're writing notes, I think bullet points are the way, but you know. What am I looking at here? It's just the README. I will say if Vim motions matter to you, Obsidian's plugin is the best. Tempted me to switch to Obsidian for that reason. Ooh. Damn. I see. That's why, because I'm looking at this and I'm looking at it and I don't see, you know, a good way to actually see my cursor, because I can't even see it. I can't even see my cursor on this. Interesting. Then what about the app you're using? What's it called again? There's another plugin that allows you to use Vim when editing, but it's trash. The app I'm using has 0 Vim support. Okay, well. But it's a great user experience if you're a Mac user. Valid, I see. The problem with me is, yeah, I'm on Windows right now, but I want a platform. I want a platform agnostic note-taking solution, you know what I mean? So Craft is the app that you use, I'm guessing. Oh wow, it's featureful. Oh, well they do have Windows support. Vision Pro web app. Vision Pro. Design Awards. Sure. Damn. There's a lot to consider. What's the pricing? Oh, it's... I don't like pricing! I get the selling point though. Okay. Lamau, Obsidian is honestly king. There's plugins to make it more like Logsec, but yeah, maybe it is. But I haven't tried one thing, which is, you know, say you got notes here, right? Say you got these notes up, okay, and say I want to type something and I want to link some ideas together from within the notes directly. If I go back, that's the slides. So I can highlight, copy text, linked references, copy ref, copy text, linked references. This is in slides, I see. You can highlight like this. Okay. Let me go to the page that I wanted to highlight. For example, this whole thing. What if I do that? Put it with a highlight. Okay. And what if I... Okay, I opened the file when I did that. What if I... Who coined artificial intelligence? What if I get rid of that for a second? 2 unlinked references. PDFs aren't part of my workflow, but that's fucking dope. It is, right? It is pretty cool actually, yeah. The name spacing feature could be good too for uni notes. Name spacing. Not sure what that what you're referring to there exactly. How do I tab? Oh, I can just tab. I just tab. Okay, right, because I wanted to say I wanted to link maybe page 26. How do I do that? You know? If I go to unlinked reference, okay, I still see the unlinked references. Let's see. Slides. HLS. Okay. You can copy the ref of that block. Yeah. Yep, that is what I did see before. Where was it again? I had 2 open instances. Copy ref. Control V. Ooh, okay. It shows the whole thing. Sure. But if I click onto it, assuming I'm on a different page, I click onto it, it just goes to that page. That's good. But if I want a specific text and not all this, I feel like there should be something better. But again, it's not all text sometimes, you know, sometimes it's just the actual image because it's some equation, right? And in this case, actually also it's just an image. So how can I copy that? Oh. You see what I see right here? Shift, drag, put whatever color you want, copy ref, paste ref, they got way more features than you could ever expect. Like, that is pretty cool. That is pretty good. For my note taking, I would actually, man. Plus, like, a lot of stuff that I'm gonna be doing, studying this subject, is gonna be PDFs, lecture slides, and I'm guessing you can toggle these. Yeah, perfect, right? Man, this is making me contemplate so hard. This is making me contemplate so hard. Look, what if I just use both, you know? Log seek and Obsidian. You know, I can always do that. And we wouldn't have issues, you know? Just say Obsidian is for one type of note taking and log seek is for another type. And honestly, I'm fine with having two separate vaults, two separate repositories, so to say. Anyway, gotta go for dinner with mates. Peace, good luck with it. Alright, epic, no worries, man. Have fun. Have fun. Thanks for tuning in anyway. Appreciate it. Okay, damn. Okay, we might be doing this. Alright. It's funny. Let me just return some messages now. Be right back. it's fun to just look at what capabilities each app has. But sometimes we can look too far. For I know that I have. And now that I've known that I have, it is time I take a step back. For I've gone too far. This is my main goal. Right, I want to look into this. I want to read this properly. Watch this properly. Understand this properly. Write notes. That's all I need. If it's gonna be a little more difficult, maybe I'm okay with that. For now. It does mean that I gotta find some way to still edit my notes properly. I mean, okay, even with logseek, you can PDF annotate, but you can't do what I want, which is write directly on the pages, right? Let me look at the selling point again. Ali Han, welcome back, man. Thanks for checking in. Me and Savasco were talking about logseek just before. Logseek versus Obsidian. And the question is, do I continue with Obsidian or do I go with logseek? It's been the question since the dawn of time. And I've spent way too much time thinking about this question. I might as well just stick with Obsidian and just continue writing notes. And just keep on writing, you know? Like, essentially what I want is, at the end of the day, what I want is to have notes that I can look back at and write questions into. And maybe, you know, I like the option of writing on the iPad so that I can actually write, like, you know, scribe on the PDF documents. Even still with that, maybe I can think of it as just replace the PDF document after you've finished scribing on it. Alihan says, it doesn't matter what tool you use, what matters is how and who uses it. yeah, how and who uses it. Yep, exactly. Who. I hope I am part of the people who use it. Right, okay. Oh, alright, you're right. You're right, Alihan. Wise words, as always. I am going to stop looking at logseek, I swear. And we're back to study. Alright. Does it feel like I can even do any... Ooh. You know, I can look into this right now. I can write a little bit of notes. Or I could do some scheduler development right now. Alihan, which should I do? I will probably do some scheduler development, I think. You know, at the end of the day, that's part of the title of this video. Alihan says, what is this? It's just my, if you're referring to what I had on before, it was just me studying. I'm just learning, preparing for the coming semester next week. Regardless, I'm going to start actually typing some words for the scheduler development. Okay. Control B. What was it? It was either colon or percent symbol. I'm going to say percent symbol. Okay. Control B. Colon symbol. Colon. Okay, Control B. It'll be shift colon. Ooh, okay, Control B, shift colon. Control B. Control B. Shift colon. Control plus B, shift plus colon. That's what I'm saying. That's what I'm saying. I don't think this is working. Hold on. Control B. Shift colon. Yeah. Okay, so it doesn't work. So Control B colon. No, Control B. It has to be shift colon. Control B, shift colon. Control B, shift colon. What am I doing wrong? Split horizontally T marks. I got it wrong. It's not colon. Control B with the double quotes. Okay, Control B. down, 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 down. I don't think. Control B up, Control B, Control B, down, down. Okay, I think Control B, down, down, down. Oh, there we go. Alright, I got it. That's what I wanted also. Why when I use Tmux all the colors disappear? I don't know, Alihan. I don't think I can even... I mean, does it look like I understand Tmux any better than you do? When I use Tmux, all the colors disappear. Can't say I know the answer to that. Oh, but I think actually you're right, because if you're talking about Neovim, you know, my colors are a little different as well. It's a little bit janky. A little bit. I'm gonna close this. And but look, right, the colors are like grayer than my default theme when without Tmux. So I kind of agree with what you're saying. Control B down. Right. Right. Docker compose up D. And then we go up a 2. And the page will refresh. Control B up. Am I happy with this? Yeah, so here's a thing that I wanted to look into, right? Today the plan was to implement creating a task, although it's an Excel task, so it's going to take some time. It's not just going to happen tonight. But I'm going to think of using React mentions. I was planning to use that. So React mentions is something I just got to read up on now. If I look at the React mentions example, so we got React mentions, lets you mention people in a text area like you use on Facebook or Twitter, use in production for all of these apps. Install the React mentions package via npm. The package exports 2 React components for rendering the mentions text area. Mentions input and mention. Mentions input, this state value, this handle change. Render user suggestion. State value, handle change. Props users. This is pretty. One more examples here. Okay. Might look at that. styling testing. Due to React Mention's internal cursor tracking, it is not good enough to simulate the editing of the text area using React Test util simulate change. We recommend using user-end for a realistic simulation of events that could happen in a browser as a user interacts with the text area. I need some sort of actual testing library installed. Alright, let's look at some of these examples. So React Mentions brought to you by this person, who I assume is the same person here. Yes. Mentions people using @ plus username or type an email address. Ooh. Do I see it? I don't see it. What about Joe? @ Right, I need the @ symbol. Jesse Pinkman. Hey, I'm not gonna... Walter White. They actually have everyone here. The OGs. Saul Goodman, Mike Ehrmantraut, Skylar White. They actually have everyone here. Okay, but Joe Smo. So if I type an email address, right? Joe @ smo.com. Oh, I see. It shows up only when you're nearing the end. Man, Joe Schmo. Single input field. Hello world. @ Walter White. Tab. Ignoring character accents. Okay. Shift tab. Hello world. What do you mean by character accents? You know? Character accent. 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 Yeah, it's accent. Scrollable container. Advanced options. Copy from here to here. Paste plain text here. Emoji support. Press. Mention people using @ emojis. Heart. Hello. Hell. I don't know why that's that. I would say that's pretty nice. That's pretty nice, all in all, you know what I mean? Suggestion portal example, bottom guard example, custom suggestions container, okay. React mentions. Alright, so here's a thing, Todoist. I need inspiration from you. Ooh. Kind of looks clean. What about assigning? Assign person plus reminder. Labels. Alright. Add extension. Let's open up ChatGPT for a second. Data parsing libraries. Value match date pattern. Okay, but yeah, moment.js is just parsing. Not what I need. Not necessary. Okay. Okay. I'm gonna end the stream now, probably. Yeah. Let me think. After I have dinner, I might be coming back. Yeah, we'll see. We'll wait. We'll wait. I just realized, very bad. Oh, this is a while ago now. QWERTY EV. I totally forgot to answer his message.
行中国，千人肥，减到70%。
是啊，简单是啊，它就是降低25%嘛。啊。就是给你25% discount。今天没走了，我就跳了5，等下再跳50。对啊，我刚才就是有滑。对，今天我只是加跳2次。
Today, we got all of these upcoming priorities. Today, calendar events. Show calendar events. Oh wow. Damn, they're following the footsteps of things. Let's see. I'm gonna say I'm good here. The Cascade. Just want to see though. Inspect HTML. Oh, flex boxes. JavaScript basics. The Cascade. In the previous lesson we covered basic CSS syntax and selectors. Now it's time to combine our knowledge of selectors with the C of CSS, the Cascade. This section contains a general overview of topics that you will learn, what the Cascade does, specificity and combining CSS selectors, how inheritance affects certain properties. The Cascade of CSS, sometimes we have rules that conflict with one another and we end up with some unexpected results, but I want these paragraphs to be blue, but are they red like these other paragraphs? But why? Right. As frustrating as this can be, it is important to understand that CSS doesn't just do things against our will. CSS only does what we tell it to do. One exception to this is the default styles that are provided by a browser. These default styles vary from browser to browser, and they are why some elements create a large gap between themselves and other elements, why buttons look the way they do, despite not writing any CSS rules to style them that way. So if you end up with some unexpected behavior like this, it is either because of these default styles, not understanding how a property works, or not understanding this little thing called the Cascade. The Cascade is what determines which rules actually gets applied to our HTML. There are different factors with the Cascade that the Cascade uses to determine this. We will examine 3 of these factors, which will hopefully help you avoid those frustrating "I hate CSS" moments. Specificity. A CSS declaration that is more specific will take precedence over less specific ones. Inline styles, which we went over in the previous lesson, have the highest specificity compared to selectors. While each type of selector has its own specificity level that contributes to how specific a declaration is. Other selectors contribute to specificity, but we're focusing only on the ones we've gone over so far: ID selectors, class selectors, and type selectors. Specificity will only be taken into account when an element has multiple conflicting declarations targeting it, sort of like a tiebreaker. An ID selector will always beat any number of class selectors. A class selector will always beat any number of type selectors. And a type selector will always beat any number of less specific selectors. Specificity will only be taken into account when an element has multiple conflicting declarations targeting it, sort of like a tiebreaker. And an ID selector will always beat any number of class selectors. A class selector will always beat any number of type selectors, and a type selector will always beat any number of less specific selectors. So ID selectors, class selectors, type selectors, let's take a look at a few quick examples to visualize how specificity works. Consider the following HTML and CSS code. So that's the HTML, that's the CSS. We got a class and we got a sure. There's a word for this. Parent-child. So in the example above, both rules are using only class selectors, but rule 2 is more specific because it uses more class selectors. So the color red declaration would take precedence. Now let's change things a little bit. We have main list subsection, blue text. So subsection is a ID and the rule, so it's blue. In the above example, despite rule 2 having more class selectors than ID selectors, rule 1 is more specific because ID beats class. In this case, the color blue declaration would take precedence and a bit more complex. So subsection, background yellow, color blue, main. Okay, well, is this not red then? Red text on yellow background. That does make sense. In this final example, the first rule uses an ID selector, while the second rule combines an ID selector with a class selector. Therefore, neither rule is using a more specific selector than the other. The cascade then checks the number of each selector type. Both rules. Okay, so in this final example, the first rule uses an ID, second rule combines an ID. Therefore, neither rule is using a more specific selector than the other. The cascade then checks the number of each selector type. Both rules have only one ID selector, but rule 2 has a class selector in addition to the ID selector, so rule 2 has a higher specificity. While the color red declaration would take precedence, the color background yellow declaration would still be applied since there is no conflicting declaration for it. Not everything adds to specificity. When comparing selectors, you may come across specific symbols for the universal selector, as well as the combinators, plus tilde, angle bracket, and an empty space. These symbols do not add any specificity in and of themselves. Here both rule 1 and 2 have the same specificity. Rule 1 uses a chaining selector, and rule 2 uses a descendant combinator. But both rules have two classes, and the combinator symbol itself does not add to the specificity. Have two classes. But both rules have two classes, and the combinator symbol itself does not add to the specificity. This example shows the same thing even though rule 2 is using a child combinator. This does not change the specificity value. Both rules still have two classes, so they have the same specificity values. In this example, rule 2 would have higher specificity, and the orange value would take precedence for this element. Rule 2 uses a type selector which has the lowest specificity value, but rule 1 uses the universal selector which has no specificity value. Inheritance refers to certain CSS properties that, when applied to an element, so let me just remember these. Chaining selector, descendant combinator, chaining selector, and descendant combinator. Inheritance refers to certain CSS properties that, when applied to an element, are inherited by the element's descendants, even if we don't explicitly write a rule for those descendants. Typography-based properties, color, font family, are usually inherited, while most other properties aren't. The exception to this, when directly targeting an element, as is always, beats inheritance. Ooh, KFC's back. Hey bro, what are you studying? I'm currently doing the Odin Project, and I'm just learning a little more about CSS before I write some of my code for the scheduler that I'm building. So yeah, just doing some of that. Okay, so inheritance refers to a certain CSS property that, when applied to an element, are inherited by the element's descendants, even if you don't specifically write a rule for those descendants. Typography-based properties, color, font size, font family, are usually inherited, while most other properties aren't. The exception to this is when directly targeting an element, as this always beats inheritance. Fair enough. So parent, child, parent ID, child will still take the blue, I believe. Despite the parent element having a higher specificity with an ID, the child element would have the color blue style applied, since the declaration directly targets it, while color red from the parent is only inherited. Rule order. Ooh, am I missing something? I feel like I'm missing some messages here. No, that's me typing to myself on Twitch chat. Ugh. Okay. Okay. So the exception to this is when directly targeting an element, as this always beats inheritance. Yep. And rule order. The final factor, the end of the line, the tiebreaker of tiebreakers. Let's say that after every other factor has been taken into account, there is still multiple conflicting rules targeting an element. How does this cascade determine which rule to apply? Whichever rule has the last defined is the winner. Alright. For an element that has both the alert and warning classes, the cascade would run through every other factor, including inheritance and specificity. Neither rule is more specific than the other. Since the warning rules have the last one defined and no other factor was able to determine which rule has to apply, it is the one that gets applied to the element. To be honest, all of these make generally a lot of sense, right? We're talking about becoming more and more specific as you go down the tree of properties to specific CSS selectors, properties, values. I think that's the right terms. And yeah, like all of this makes foundational sense, you know, like go back to our CSS exercises repository and navigate to the foundations directory, review the README and complete the final exercise. Note the solution for these exercises can be found in the solutions folder of each exercise. So I won't take too much time here. I'll go to that page because I have it. Control BD, clear, we go to TOP and NVIM, CSS exercises. Right, yeah, I actually open up, I need to go to CSS exercises, NVIM here. Let's control quit this one, control quit, control X, control X, control X, and just have a look at some of these other ones that I've not really taken a look at in depth. I will just open it up. Okay, solution HTML. Okay. Index HTML. What difference is there to this? Inverted and fancy. Inverted and fancy. Inverted and fancy. That's pretty much the only difference. Let's go to the solution.css. We're going to have a style.css to look at, but the solution.css is just font family, Helvetica, Times New Roman, and sans serif as the priorities. Font size, fair enough. Background color. So the one thing I almost overlooked is the dot inverted, colon dot fancy. I'm guessing this is just what both of these have on top of their individual classes, the individual selectors. So as a selector inverted, you have black and white, and as fancy you have just a yellow background, whereas you both have these. And looking at the solution, you'd have to have a look at this by opening it up, except how would you open it up? If I remember it correctly, explorer.exe followed by the destination, so foundations. Foundations, we do 03 tab, and then we do solution, and then we do solution.html -1. That's fine, because I think you have to be directly in that place. So let's see, I will go down the tree to foundations, foundations 03 solution. Okay, explorer.exe index HTML. Oh, right, it's solutions.html. Explorer.exe solution HTML. And it opens it. I think I understand why, you know? I understand why now, okay? Alright, so let's go now to 04. .04 chaining selectors, solution. Alright, so I'm gonna just go to Nvim and take a look at solutions. Okay, I'll go to index.html. Just why? That's not what I wanted. Okay, here we go. Solutions CSS, avatar proportioned, avatar distorted. This is a hierarchical combinator. Was that what it's called? No, I don't think that was what it's called. I'm gonna go back. I'm gonna have to shift tab. I made a mistake. Okay, I'm here. I need to find combinator. Where does it say combinator? It's definitely descendant combinator. Descendant combinator was the name. Regardless, I probably need to go to P and just scroll down until I get to intro to CSS, and we're gonna have to also have an understanding of the descendant combinator. So we're gonna have to search for descendant combinator. Alright, so that it's called a descendant combinator, and that makes sense. This isn't a descendant combinator then. This is a chaining selector. Chaining selector, yeah. Versus descendant combinator. I have to remember those two terms rightfully. I need to remember those two terms correctly. I wish I knew how to close this without a keyboard. Oof. Okay. So that's fine. We're going to go back up a little bit and just have a read more. So if I go here, so this is a chaining selector, and this is where is it? Link rel style sheet. Device width, initial scale. Avatar proportioned. Original proportioned. Original distorted. Oof. Avatar distorted. Original proportioned, original distorted. Avatar proportioned, avatar distorted. I'm guessing those just didn't have, or check the image source review foundations. Solution.css. What's the CSS for? Just the style. Nothing. Okay, so we're just gonna quit now. We're going to explorer.exe, the index. No, we're going to go to solutions. Index, explorer, solution.html. Wow. What type of meme format are we building? Alright, sure, and then... So I want to just check that these make sense. Distorted, right. So the height is auto and that is distorted. If we go back to the previous page, the height becomes auto, the width is decreased. Makes sense. It all makes sense. I am fine with that. Okay, and we go now to 05. Tab and Vim. Let's have a look. Index HTML. Style.css, still nothing inside. Solution CSS. Lower some possible descendant combinators. So these are descendant combinators. Div p, div.text, container p. So I'm guessing the solution here is to not be changed with respect to the index.html here. So if I just tab between the two, they don't get changed. Yep. Mad. And these are the only differences. And index.html solution. Background color yellow, color, font size, text align. Now we're basically saying that we want div p and container text to be equivalent. So container followed by text, text, container, text. Some alternatives are div p, div text, container p, obviously. Makes sense. Okay. There's no need for me to see that file. I just remembered a dream that I had. Damn. Undo. No. No difference. Ooh. This is huge. What am I looking at? Style.css, is this the same? It is. So I want to give you a closer look at the cascade, in particular specificity and rule order. Both HTML and CSS files are filled out for you, so instead of adding rules yourself, you will simply be editing what is provided. There are a few elements that have some sort of specificity or rule order issue in the provided CSS file. It is up to you to figure out what issue is affecting an element and how to fix it. You can edit the CSS file by adding, removing, or editing selectors for a declaration block, or by moving declaration blocks around. You should not edit the HTML file or in any of the actual styles in the CSS. There are multiple ways to solve this exercise, and we did our best to include all the possible solutions for each element. Issues with the cascade can be the bane of their existence for many, and when it comes to CSS. When you won't become Cascade expert from this exercise alone, and there are other ways to deal with these issues, it is still super helpful to see those issues affect our final styles, and why it's important to order rules carefully. Desired outcome, self-check. Did you add selectors to the CSS? Do they target a valid HTML element? Child. Small para. For the following rules, in the file. confirm button. Okay. Okay. Note solutions can be found in the solutions folder. Remember the recipe page you created as a practice from HTML? Well, it's rather plain looking, isn't it? Let's fix that by adding some CSS. How you actually style it is completely open, but you should use the external CSS method for this practice and moving forward. You should also try to use several of the properties mentioned in the previous lessons: color, background, typography, properties, etc. Take time to play around with the various properties to get a feel of what they do. For now, don't worry at all about making it look good. This is just a practice and get used to writing CSS, not to make something to show off on your resume. We haven't covered how to use a custom font or the font family property yet, so for now take a look at the CSS fonts for a list of generic font families and to use web safe. What was that? Web safe fonts for a list of fonts that are web safe. Web safe means that they are fonts that are installed on basically every computer or device, but be sure to still include a generic font family as a fallback. Web3 schools. Additional resources, the following questions. Okay, between a rule that uses one class selector and a rule that uses 3 type selectors, which rule has the highest specificity? One class selector. Additional resources. This section contains helpful links to related content. It isn't required, so consider it supplemental. So the CSS Cascade. Ooh, they made something pretty. This is really nice. D. This is a video on the Cascade probably. Okay, I don't need to watch that. Allows you to fill in the own selectors and have their specificity calculated and visualized. Specificity calculator. What are we working with here? One, 1, 2. 1, 1, 2. I see. Ooh, there is a long list. There is a very long list. Yep, I'm happy just browsing over that. Color property, what's this? So can be used to learn if a particular CSS property is inherited or not. Look for the inherited field inside the formal definition. Here's an example of a CSS color property. Oh, right. Inherited. Right. So if we're talking about KF, for example, if we're looking at SF, column count is not an inherited property. So what all makes sense there. Inherited interactive scrim on the CSS Cascade. I see. It's alright. I'm good with that. SJ. K. Inspecting HTML and CSS. Ooh, this is going to be interesting. This is what I kind of need, to be honest. Inspecting HTML and CSS in the Cascade. Before I continue, let me just go to the end and just view the course again. I just need myself an overview. Inspecting HTML and CSS, block and inline. I honestly will be happy to read over all of this stuff as fast as I can before even doing the next, I guess, phase of things that I need to do to create a task manager. Right. So let me go back to scheduler for a second. And what I need to understand is my next steps. I need, let's see. If I need to understand my next steps, I need to go through the tabs. Okay. I can't go back now. Can't go forward either. Get back all the way to the beginning. Alright. DG. JW. So KG. Investigate React mentions. Okay, React mentions. I will say I have done the investigation now, and we're going to have also Data table. Documentation. She wants K's. Keep it up. Keep up the hard work. Thank you, man. Or woman. Thank you for the hard work. I mean, what am I saying? Appreciate it. And thank you for the follow. That's what I wanted to say. Okay, so inspecting HTML and CSS. So we've got to Okay, more than halfway through the Foundations course. Being able to inspect and debug your HTML and CSS is critical for front-end development. This lesson will take us through the Chrome DevTools, which allows you to see detailed information about your elements and CSS rules, as well as assist you in finding and fixing problems in your code. This section contains a general overview of topics. You will know how to access the element inspector. You will know how to select and inspect specific elements. You'll know how to test out HTML and CSS inside the inspector. The inspector, to open the inspector, you can right click on the element of a web page and click inspect or press F12. Go ahead and do that right now to see the HTML and CSS used on this page. Do not get overwhelmed with all the tools you're seeing. For this lesson, we want to focus on the elements and styles panel. So inspector, elements and styles. Yep, so you can see the entire HTML structure of your page. You can click on any of the elements in this panel to see that specific element. Alternatively, you can click in the blue highlighted icon shown below on the left and hover over any element on the page. Right. That's what I was missing. Control-Shift-C. Control-Shift-C. Right. That's really nice. When an element is selected, the Styles tab will show all the currently applied styles as well as any styles that are being overwritten. Okay, wait, I didn't even look at this page very well. Elements, components. When an element is selected, your Styles tab will show all the currently applied styles, as well as any styles that are being overwritten, indicated by a strike through of the text. For example, if you use the inspector to click on the Your Career in Web Development Starts Here header, on the top home page, on the right hand side, you'll see all styles that are currently affecting the element as shown below. Currently applied style. Overwritten style, margin bottom, I see. That makes sense as to the strike-throughs. Testing styles in the inspector. The style panel allows you to edit styles directly in the browser. You can click inside of any of the individual selectors to add a new rule, or click on the existing attribute or value or two after it. In doing so, the web page corresponds. Ooh! Thank you, Embrim, for subscribing. Testing styles in the inspector. The styles panel also allows you to edit styles directly in the browser. You can click inside of any individual selector to add a new rule, or click on an existing attribute or value to alter it. When doing so, the web page responds with the changes in real time. This won't affect the source code in your text editor, but it is extremely useful for quickly testing out various attributes and values without needing to reload the page over and over again. So go through the following selections on the official Chrome DevTools docs, DevTools overview, open Chrome DevTools, similar to what we went over, with some nice extras. Get started with viewing and changing the DOM. View and change CSS. Be sure to follow along with any interactive instructions. Knowledge check. So how do you select a specific element on your page? Just click that button. What does a strike through? It means it is overwritten. How do you change CSS in real time on a specific element on a web page with your browser developer tools? Well, you can just go to the styles panel. Additional resources. This section contains helpful links to related content. It isn't required. The article about how we can utilize CSS overview in the developer tools. To check the colors, font styles, media queries, etc. used on a particular web page. Okay. Alright, okay, so J. to use CSS Overview in Chrome DevTools. What is CSS Overview? It is based on the color used on a web page, line height, blah blah blah. When on Chrome DevTools. How to access Chrome developer tools in your browser. DevTools, inspect, shortcut, Option Shift I. How to use in DevTools, open DevTools, click on more. Tools, CSS Overview. Is that true? CSS. Bird's name is CSS. That's why it's so good.
There are different ways to open Chrome. DevTools. Tell me your way in the comment below. Meanwhile, I will show you all the ways to access different parts of the DevTools UI. First, there are 3 keyboard shortcuts you can use. Here is an easy way to remember them. C, J, and I. C for CSS, J for JavaScript, and I for my choice. Let's dive in. If you like to inspect an element's attributes for CSS, you can use Command Option C in Mac OS or Control Shift C in Windows or Linux. This way, you can access the Elements panel faster. Can you see the little inspect icon highlighted in blue? That indicates to you that DevTools is now in the inspect mode. Power over to any elements on screen. It is highlighted to the element. Now, let's say you want to inspect the style. Click the element in the style screen. Next, if you are mostly focused on JavaScript, you might want to open the console directly with the J shortcut. While you are in this page, press Command Option J in Mac OS or Control Shift J in other OS to jump straight into the console. From here, you can view log messages or run JavaScript right away. All these are great. Let's look at the last panel. Guess what? There is a shortcut for that. For example, you are on the network panel. You want to refresh and restart the network log. You could of course clear the network log with this method. However, you can use a keyboard shortcut as well. It might be quicker to do it with Command Option I or Control Shift I shortcut.
好，洗碗。
Open the same panel. This
你们不要大惊小怪啊！你就搞你的，我就搞我的啊！别大惊小怪。
I mean, okay, fair enough. Never thought I'd be watching that video. But that was pretty much, yeah, okay, that's pretty much the whole slide. What was it that said skip through any part that uses the JavaScript console? FW.
explore two of the most confusing web development terms. Let's begin! When you use a browser to request a web page, the server returns HTML like this. The HTML is a document with instructions on how the page is roughly look like. The browser uses a process to parse the HTML to create a tree of objects like this. Each object of the tree is a node. This entire tree representing the page's content is the DOM, or we call it the document object model. Right now, the DOM looks the same as the HTML, but suppose that the script reference at the bottom runs this code. It removes the heading nodes and adds another paragraph node to the DOM. The complete DOM now looks like this. The page's HTML is now different from its DOM. In other words, HTML represents initial page content and the DOM represents current page content. When JavaScript adds, removes, or edits nodes, the DOM becomes different from the HTML. In fact, when building a page with a JavaScript framework, you can use a very short HTML document and add all the nodes from JavaScript. That works. The browser will parse it the same way to form the DOM. With that, let's inspect the page with DevTools. There are more than 5 ways to open DevTools. You can watch my previous video to learn more. Right-click on the page and select Inspect. This is the Elements panel. On the left is the DOM tree. This is where you can inspect, edit, and do all DOM-related activities. When you are interested in a particular DOM node, Inspect is a fast way to investigate that node. With that, the node is highlighted in the DOM tree. Furthermore, as you navigate the nodes, DevTools highlights the node in your page too. There are 3 more handy commands to help you locate your node quicker. You can use Ctrl or Command F to search through the DOM. If you find the DOM node is not currently in the viewport, instead of scrolling all the way to the bottom, you can click on the 3 dot and select Scroll into View. In addition, do you see the $hint in the DOM tree? You can press Escape to bring up the console and type $0 to view the current node. You can also modify the text content on the fly using this command. To view the node in object format, you can use the dir command. If you want to view your previous node in the navigation history, type $1 type $0 to view the current node. You can also modify the text content on the fly using this command. To view the node in object format, you can use the dir command. Type $0 to view the current node. You can also modify the text content on the fly using this command. To view the node in object format, you can use the dir command. If you want to view your previous node in the navigation history, type $1 will get you that. Similarly, you can right-click and scroll to view from here. This $command is part of the Console Utilities API. Go to this video to learn more useful commands like this. Since we touched on editing the DOM, there are multiple easier ways to edit it as well. This allows you to quickly experiment changes in the UI. To edit the text content of a node, double-click on the text and start editing. Press Enter to apply the changes. Similarly, if you want to change the type of this node, double-click it, enter the new type, and press Enter. To add a new attribute like applying styles to the element, you can right-click, select Add Attribute. Type in your attribute name and value. Look at that, the color changed to deep pink. By the way, you can use Tab to navigate through the attributes. For example, double-click on the node and press Tab. It will jump to the first attribute and you can edit the value on the fly. If you want to add a hyperlink, adding an anchor node like this doesn't work because DevTools passes that as text. Right-click on the node and select Edit as HTML. Paste in your anchor and press Enter. Easy peasy. Now, here is a lesser known feature. You can drag and drop the DOM node to move them around. Once you are done with your changes, you can right-click and take a node screenshot, then send it to your designer. Take note though, DevTools won't save the changes you make in the DOM. All changes are gone after you reload the page, even if you have set up a workspace. That makes sense, because it's the DOM. DevTools doesn't know where and how to save the changes. Should it be the HTML or JavaScript? With Workspace, you should edit the actual file in the Sources panel to save changes to your source code. Alright, that's all for now. To learn more about manipulating the DOM with DevTools, visit this link. Happy coding and stay tuned for the next DevTools tips. Ciao!
My golly god. Once I finally get through these last few sections, I'll be a god. I'll be a god. I'll just know things. I'll just know things. Man, okay. Good overview, I must say. I'm gonna finish this last thing before just being completely done. Done with it all. Ooh, you guys can go to the actual GitHub pages of these people. Interesting. His personal website.